As you listen now, the story of the universe begins to unfold. Every star, every breath, and every heartbeat is built from the 118 elements of chemistry. Tonight, we will explore their stories one by one, in calm and simple words. Along the way, we will meet 8 new elements that many students never knew existed, and discover the hidden secrets that make each element unique and wonderful. Welcome to Success Academy TV, where science is told like a bedtime story. If you enjoy relaxing lessons, please subscribe, ring the notification bell, and share this with a friend. Your support helps us create more peaceful learning experiences for everyone. Now, take a slow breath, relax your mind, and let us begin our gentle journey through the periodic table. Close your eyes and imagine floating through space, where our story begins with the simplest element of all. Hydrogen, the first light. Hydrogen is the first element, the lightest of all. With atomic number 1 and weighing just 1.008 atomic mass units, it fills the stars and makes up most of the universe. Each atom has only 1 proton and 1 electron, so simple yet so powerful. Hydrogen lives in group 1 of the periodic table, but it stands alone, different from all metals below it. This colorless gas burns with a pale blue flame when it meets fire. At -259 degrees Celsius, it becomes a liquid as clear as water. Hydrogen fuels the sun and gives us light, creating helium in the process. Fun fact, hydrogen gas is so light it can make your voice squeaky, just like helium, but it is much more dangerous to breathe. In water, hydrogen bonds with oxygen in perfect harmony. It is the most abundant element in the universe, making up about 75% of all matter. From this cosmic fire, the second element is born, floating peacefully in the air above us. Helium, the gentle giant. Helium is soft and calm, with atomic number 2 and atomic mass 4.003. It lives in group 18, the noble gases, filling balloons that rise into the sky. In the stars, helium shines with steady light. It does not like to react with others, keeping its peace in perfect isolation. This colorless gas makes voices high and squeaky when breathed safely in small amounts. Helium becomes liquid at -269 degrees Celsius, colder than almost anything else. It feels like a quiet smile of the universe, never angry, never reactive. Fun fact, helium can flow uphill and leak through solid glass because its atoms are so tiny. On Earth, helium comes from deep underground, trapped in rocks for millions of years. It escapes into space and never comes back, making it precious and rare. After helium's gentle calm comes lithium, small but fiery, waiting to dance with energy. Lithium, the silver spark. Lithium is a gentle metal but full of hidden power. With atomic number 3 and atomic mass 6.941, it sits in group 1, period 2 of the periodic table. This soft, silvery metal can be cut with a knife like butter. It powers your phone and laptop batteries, storing energy in tiny spaces. When lithium meets water, it dances and burns with a bright red flame, floating on the surface like a glowing ember. It shows how energy can be stored in tiny atoms. Fun fact, lithium is so light it floats on water, the lightest metal of all. Your body needs tiny amounts of lithium to keep your mind healthy and balanced. Lithium comes from salt lakes and special rocks called spodumene. As our world uses more batteries, lithium becomes more valuable than silver. From lithium's gentle spark, we move to beryllium, strong but quiet, hiding its power in silence. Beryllium, the sweet poison. Beryllium is rare but incredibly strong. With atomic number 4 and atomic mass 9.012, it lives in group 2, period 2. This steel-gray metal tastes sweet but is dangerous to touch or breathe. It is hidden deep in emerald crystals and special minerals, giving emeralds their beautiful green color. Beryllium is 6 times stronger than steel but weighs much less. It helps metals become harder and is used in windows that let X-rays pass through to see inside your body. Fun fact: beryllium is so strong that a beryllium guitar would ring with perfect sound for hours. But you must never touch it without gloves. Space rockets use beryllium because it stays strong even in the coldest space. It reflects heat like a mirror, protecting spacecraft from the sun's burning rays. Beryllium is like a silent shield, strong but hidden. After beryllium's quiet strength, boron steps in as a master builder. Boron, the bridge builder. Boron helps plants grow and makes glass stronger than steel. With atomic number 5 and atomic mass 10.811, it lives in group 13, period 2. This dark, almost black element stands between metals and nonmetals, building bridges in the periodic table. It can be shiny like metal or dull like coal. Boron burns with a green flame, adding color to fireworks. It is found in soil, soap, and cleaning agents that make your clothes bright and clean. Fun fact: boron is essential for healthy bones and helps your brain think clearly. Plants die without boron in the soil. The hardest substance after diamond contains boron, creating tools that can cut through anything. Boron whispers strength into fiberglass that makes boats and cars. Quiet but useful, it always supports life. And just after boron comes carbon, the magical element of life itself. Carbon, the shape shifter. Carbon is the backbone of all living things. With atomic number 6 and atomic mass 12.011, it rules group 14, period 2. This amazing element can be black as coal, clear as diamond, or slippery as graphite in your pencil. Carbon's creativity knows no bounds. As diamond, carbon becomes the hardest natural substance, sparkling with rainbow light. As graphite, it becomes so soft you can write with it. As soot, it turns deep black, absorbing all light. Fun fact: your body is 18% carbon, making you a walking carbon factory. Every breath you take releases carbon dioxide. Carbon forms more compounds than any other element, creating plastics, medicines, and every molecule in your body. It makes the sugar that gives you energy and the DNA that makes you unique. Carbon's gift fills the earth with endless forms of life. From carbon's creative dance, nitrogen quietly takes its place in the air around us. Nitrogen, the silent supporter. Nitrogen makes up 78% of the air you breathe. With atomic number 7 and atomic mass 14.007, it lives in group 15, period 2. This colorless, odorless gas surrounds you every moment, silent and invisible but absolutely essential for life. Nitrogen becomes liquid at -196 degrees Celsius, so cold it can freeze anything instantly. Plants and animals need nitrogen to grow, but they cannot use the nitrogen in air directly. Fun fact: nitrogen makes your voice deeper underwater and can make you feel dizzy if you breathe too much pure nitrogen. Lightning turns nitrogen in air into fertilizer that plants can use. Without nitrogen, there would be no proteins in your body, no green in plants, no life on Earth. It connects the soil, the air, and living bodies together in perfect harmony. From nitrogen's quiet support, oxygen arrives to breathe life into the world. Oxygen, the breath of life. Oxygen is the breath of life itself. With atomic number 8 and atomic mass 15.999, it commands group 16, period 2. This colorless gas helps fire burn and keeps you alive each second of every day. You cannot see it, smell it, or taste it, but you cannot live without it. Oxygen becomes pale blue liquid at -183 degrees Celsius. It makes up 21% of air and nearly half of the Earth's crust. It bonds with hydrogen to form water, the most precious gift on Earth. Fun fact, oxygen is magnetic and will stick to powerful magnets. It also glows green in the northern lights. Your blood carries oxygen in red cells, turning bright red when full of oxygen and dark red when empty. Oxygen feeds the fire inside your cells that gives you energy to move, think, and dream. After oxygen's life-giving power, fluorine arrives with its sharp, dangerous edge. Fluorine, the dangerous beauty. Fluorine is the most reactive element in the universe. With atomic number 9 and atomic mass 18.998, it rules group 17, period 2. This pale yellow gas is so dangerous it can burn through glass, concrete, and even water. Nothing can contain pure fluorine except special metals. Fluorine becomes liquid at -188 degrees Celsius, glowing with a faint yellow light. Yet this dangerous element protects your teeth in toothpaste and makes non-stick pans slippery. Fun fact, fluorine is so reactive it was not isolated until 1886, and several scientists died trying to capture it. Your bones and teeth contain fluorine compounds that make them stronger than steel. Fluorine creates the slipperiest substance known, making things so smooth that almost nothing sticks to them. It shows the wild, untamed side of chemistry. After fluorine's dangerous dance, neon appears, glowing calm and peaceful. Neon, the night light. Neon is quiet and beautiful, glowing like a rainbow. With atomic number 10 and atomic mass 20.180, it rests peacefully in group 18, period 2. This colorless gas does not react with anything, staying pure and noble forever. When electricity flows through neon, it glows with orange-red light. Neon becomes liquid at -246 degrees Celsius, almost as cold as space itself. It fills signs that light up cities at night, bringing life and color to darkness. Fun fact, neon was discovered by studying the leftover air after oxygen and nitrogen were removed. It was literally hiding in plain sight. Different gases can make neon tubes glow in many colors, but true neon always glows orange-red. It is so rare that you could collect all the neon in a large room and it would fit in a small bottle. Neon lights shine in cities worldwide, a silent lamp that never burns out. After neon's gentle glow, sodium's fiery energy rises like a flame. Sodium, the energetic dancer. Sodium is soft, silvery, and full of restless energy. With atomic number 11 and atomic mass 22.990, it leads group 1, period 3. This shiny metal is so soft you can cut it with a butter knife, revealing a bright silver surface that quickly turns dull in air. Sodium burns with a bright yellow flame, the same color as street lights. In your body, sodium helps nerves send lightning-fast signals to your muscles and brain. Fun fact: sodium is so reactive it must be stored under oil to keep it from exploding in air. A tiny piece dropped in water creates a fiery dance across the surface. Table salt contains sodium bonded peacefully with chlorine, showing how even dangerous elements can become safe and useful. Your taste buds crave sodium because your body needs it to survive. Sodium is restless and never found alone in nature. After sodium's energetic rush, magnesium arrives with strength and brilliant light. Magnesium, the white fire. Magnesium burns with a bright white light that can blind your eyes. With atomic number 12 and atomic mass 24.305, it shines in group 2, period 3. This silver-white metal is light as aluminum but strong as steel. When magnesium burns, it creates light brighter than the sun. Magnesium becomes liquid at 650 degrees Celsius, glowing like molten silver. It is in your bones and teeth, making them strong. Green plants use magnesium in chlorophyll to turn sunlight into food. Fun fact: magnesium ribbon burns so brightly it was used in old camera flashes and still lights up fireworks today. Your heart needs magnesium to beat steadily, and your muscles need it to move smoothly. Magnesium is the 8th most common element in the Earth's crust, hiding in rocks, sea water, and every green leaf. It glows with steady strength, the metal of life itself. From magnesium's brilliant fire, aluminum shines next with modern versatility. Aluminum. The modern metal. Aluminum is light and useful, shaping the modern world. With atomic number 13 and atomic mass 26.982, it rules group 13, period 3. This silvery white metal reflects light like a mirror and weighs 3 times less than steel. It bends easily but never breaks under normal use. Aluminum melts at 660 degrees Celsius and conducts electricity almost as well as copper. It resists rust by forming a protective invisible coating in air. Fun fact: aluminum was once more valuable than gold because it was so hard to extract from rocks. Napoleon served his most honored guests with aluminum utensils while less important guests used gold. Today aluminum shapes cans, foil, airplanes, and spacecraft. It is recycled forever without losing strength, making it the green metal of the future. Though common now, it feels modern and bright, reflecting the innovation of human science. From aluminum's shiny versatility, silicon steps in as the thinking element. Silicon, the digital brain. Silicon is the foundation of all computers and smartphones. With atomic number 14 and atomic mass 28.085, it commands group 14, period 3. This dark gray element looks like metal but acts like a bridge between metals and nonmetals. Pure silicon shines like polished steel. Silicon melts at 1414 degrees Celsius and forms crystals harder than steel. It creates glass, sand, and the tiny chips that hold digital memories. Fun fact: silicon makes up 27% of the Earth's crust, second only to oxygen. Every grain of sand on the beach contains silicon. Computer chips carved from pure silicon crystals think faster than human brains, storing millions of photos, songs, and memories in spaces smaller than your fingernail. Without silicon, modern life would stop completely. It connects the ancient Earth with futuristic technology in perfect harmony. From silicon's digital brilliance, phosphorus glows next with mysterious light. Phosphorus, the glowing mystery. Phosphorus glows softly in the dark with an eerie green light. With atomic number 15 and atomic mass 30.974, it illuminates group 15, period 3. This element appears in many forms. White phosphorus glows and burns in air, while red phosphorus stays safe and stable. White phosphorus melts at only 44 degrees Celsius and burns your skin on contact. It helps plants grow and keeps your body alive in DNA, bones, and teeth. Fun fact, phosphorus was first discovered in human urine and literally means light bearer in Greek. It was the first element discovered that glowed in the dark. Every living cell contains phosphorus, storing energy like tiny batteries. Matches contain phosphorus that lights with friction, bringing controlled fire to humanity. It balances between life and danger, creation and destruction. From phosphorus' mysterious glow, sulfur brings its sharp, unforgettable smell. Sulfur, the smelly treasure. Sulfur smells sharp and strong, like rotten eggs or burning matches. With atomic number 16 and atomic mass 32.065, it dominates group 16, period 3. This bright yellow element appears as beautiful crystals that feel smooth and light. Pure sulfur looks like golden honey when melted. Sulfur melts at 115 degrees Celsius and burns with a blue flame that dances like liquid fire. It is found in volcanic rocks and hot springs around the world. Fun fact, sulfur creates the smell of rotten eggs, onions, and skunks. Your hair and nails contain sulfur compounds that make them strong. Medicine uses sulfur to fight infections and skin diseases. It vulcanizes rubber, making car tires strong and flexible. Though strong in smell, it is vital for all life on Earth. After sulfur's pungent power, chlorine comes with strength to protect and clean. Chlorine, the green guardian. Chlorine keeps water safe to drink and pools clean to swim in. With atomic number 17 and atomic mass 35.453, it guards group 17, period 3. This yellow-green gas is sharp and powerful, with a smell like bleach that warns you to stay away. Chlorine becomes liquid at minus 34 degrees Celsius, appearing as a golden yellow liquid. It kills harmful bacteria and viruses, protecting millions of lives every day. Fun fact, chlorine gas was used as a weapon in World War I, but now it saves more lives than almost any other chemical. Table salt contains chlorine bonded peacefully with sodium, proving that dangerous elements can become gentle and necessary. Your stomach makes hydrochloric acid with chlorine to digest food safely. Chlorine is a guardian, strong but sometimes harsh, always protecting life. After chlorine's sharp protection, argon arrives, silent and invisible. Argon, the invisible guardian. Argon is a noble gas, calm and completely invisible. With atomic number 18 and atomic mass 39.948, it rests in group 18, period 3. This colorless, odorless gas makes up about 1% of the air you breathe, but you never notice it is there. Argon becomes liquid at minus 186 degrees Celsius, appearing as clear as water. It fills light bulbs and protects metals from rusting during welding. Fun fact, Argon's name means lazy in Greek because it never reacts with anything. It was discovered by removing all other gases from air and seeing what was left. Argon surrounds precious metals during welding, creating a protective bubble that keeps them pure and strong. It prefers to stay alone, never forming compounds, a silent companion floating peacefully in every breath. From argon's invisible stillness, potassium bursts in with electrical life. Potassium, the heart's electric friend. Potassium is vital for every heartbeat and nerve signal in your body. With atomic number 19 and atomic mass 39.098, it energizes group 1, period 4. This soft, silvery metal tarnishes instantly in air, turning from bright silver to dull gray in seconds. Potassium burns with a beautiful purple flame and reacts explosively with water. It becomes liquid at 63 degrees Celsius, not much hotter than a very hot summer day. Fun fact: bananas contain so much potassium they are naturally radioactive. Your body contains about 140 grams of potassium, mostly in your muscles. Every nerve in your body uses potassium to send electrical signals to your brain. Your heart depends on potassium to beat steadily and strongly. Potassium is soft, silvery, and full of life-giving energy. From potassium's electrical spark, calcium steps in with strength for bones and shells. Calcium, the bone builder. Calcium builds the strong foundation of all life with bones and shells. With atomic number 20 and atomic mass 40.078, it constructs group 2, period 4. This silver-white metal burns with a brilliant red-orange flame and reacts gently with water. Calcium melts at 842 degrees Celsius and glows like hot coals when heated. It is found in milk, cheese, and every dairy product. Fun fact: calcium makes up 2% of your body weight. Without it, you would collapse like a jellyfish. Seashells and coral reefs are built entirely from calcium compounds. Your teeth contain calcium that makes them harder than most metals. Chalk, marble, and limestone are all forms of calcium carbonate, the same stuff in eggshells and pearls. Calcium is the steady, strong frame that holds life together. After calcium's solid strength, a new row of elements begins with rare scandium. Scandium, the light strengthener. Scandium is rare and light, hidden in the earth like buried treasure. With atomic number 21 and atomic mass 44.956, it begins the transition metals in group 3, period 4. This silvery white metal is lighter than aluminum but stronger than steel when mixed with other metals. Scandium melts at 1541 degrees Celsius and glows with brilliant white light when heated. It strengthens baseball bats and bicycle frames without adding weight. Fun fact: scandium is rarer than gold but less valuable because few people know about it. It was predicted by Mendeleev before it was discovered. Aerospace engineers love scandium because it makes aluminum alloys incredibly strong for spacecraft and jet engines. Though seldom seen, it gives strength without adding weight to the things that help us fly. Scandium is like a quiet helper in modern technology. After scandium's hidden support, titanium steps forward with legendary power. Titanium, the indestructible beauty. Titanium is as strong as steel but half the weight, shining like liquid silver. With atomic number 22 and atomic mass 47.867, it dominates group 4, period 4. This gorgeous metal resists rust, acid, and even sea water, staying beautiful forever. Titanium melts at 1668 degrees Celsius and burns with sparkling white light. It is used in jet engines, spacecraft, and artificial hips that last a lifetime inside your body. Fun fact: titanium is named after the Titans, the powerful giants of Greek mythology. Your body accepts titanium implants as if they were natural bone. The white paint on your house contains titanium dioxide, the whitest white substance known. Titanium jewelry never turns your skin green and lasts forever without tarnishing. It is strength with grace, balancing incredible toughness with elegant beauty. From titanium's perfect strength, vanadium arrives with flexible power. Vanadium, the flexible warrior. Vanadium makes steel that bends without breaking, like a sword that never snaps. With atomic number 23 and atomic mass 50.942, it flexes in group 5, period 4. This gray metal adds incredible strength and flexibility to tools and bridges that must bend in the wind. Vanadium melts at 1910 degrees Celsius and creates beautiful colored compounds: yellow, orange, green, and blue. It is a secret ingredient in the strongest steel on Earth. Fun fact: some sea creatures use vanadium in their blood instead of iron, giving them blue or green blood instead of red. Car springs and shock absorbers contain vanadium steel that bounces back from every bump and pothole. Though not famous, vanadium holds enormous value in creating metals that are both strong and flexible. It teaches us that true strength can also be gentle. After vanadium's quiet flexibility, chromium arrives with mirror-bright shine. Chromium, the mirror maker. Chromium makes metals shine like perfect mirrors, reflecting light like still water. With atomic number 24 and atomic mass 51.996, it polishes group 6, period 4. This steel gray metal never rusts and always stays bright and beautiful. Chromium melts at 1907 degrees Celsius and creates the most brilliant colors in nature. It gives emeralds their deep green glow and rubies their rich red fire. Fun fact: chromium's name means color in Greek because it makes more beautiful colors than almost any other element. Chrome bumpers on classic cars contain chromium that shines for decades without fading. Stainless steel contains chromium that prevents rust forever. Your body needs tiny amounts of chromium to process sugar properly. From chromium's dazzling sparkle, manganese adds quiet strength to steel and soil. Manganese, the quiet helper. Manganese strengthens steel and helps plants grow in perfect balance. With atomic number 25 and atomic mass 54.938, it serves faithfully in group 7, period 4. This gray-pink metal works behind the scenes, making other elements stronger and better. Manganese melts at 1246 degrees Celsius and burns with a greenish-white flame. Every steel railroad track and skyscraper contains manganese for strength. Fun fact: manganese nodules cover the deep ocean floor like metal potatoes, created over millions of years by slow chemical reactions. Your brain needs manganese to think clearly and your bones need it to grow strong. Without manganese, plants cannot make chlorophyll and would turn yellow and die. It hides quietly in soil and steel but plays an essential role in all life. From manganese's humble service, iron takes center stage in the story of civilization. Iron, the blood of earth and humanity. Iron builds the modern world and flows through your veins as the heart of blood. With atomic number 26 and atomic mass 55.845, it commands group 8, period 4. This silvery metal turns red-brown when it rusts, painting old buildings and abandoned cars with the colors of time. Iron melts at 1538 degrees Celsius and glows like a tiny sun when heated. It is magnetic and will stick to magnets with surprising strength. Fun fact: your blood is red because of iron atoms sitting in the center of every hemoglobin molecule. The Earth's core is mostly iron, making our planet magnetic. Humans discovered iron making about 3,000 years ago, ending the Bronze Age and beginning the Iron Age. Every red blood cell in your body carries iron that grabs oxygen in your lungs and delivers it to every cell in your body. Iron is strength, structure, and the foundation of all complex life. After iron's fundamental power, cobalt adds brilliant color and energy. Cobalt, the blue beauty. Cobalt creates the most beautiful blue color in pottery and glass that never fades. With atomic number 27 and atomic mass 58.933, it energizes group 9, period 4. This hard, gray metal produces stunning compounds in shades of deep blue, pink, and purple. Cobalt melts at 1495 degrees Celsius and is strongly magnetic like iron and nickel. It powers rechargeable batteries in phones and electric cars. Fun fact: cobalt blue paint has colored pottery and art for over 1,000 years and still looks as bright as the day it was painted. Vitamin B12 has a cobalt atom at its center. Your body needs tiny amounts of cobalt to make healthy red blood cells and repair damaged nerves. The brightest blue in ancient Chinese porcelain comes from cobalt that traveled the Silk Road as a precious trade good. After cobalt's brilliant blue, nickel arrives with enduring strength. Nickel, the eternal coin. Nickel resists rust and corrosion, staying bright and strong forever. With atomic number 28 and atomic mass 58.693, it endures in group 10, period 4. This silvery white metal is magnetic and feels heavy and solid in your hand. Nickel melts at 1455 degrees Celsius and stays shiny even in harsh weather. American nickels contain 25% nickel mixed with 75% copper. Fun fact: nickel was first found in meteorites from space, and the Earth's core contains massive amounts of nickel mixed with iron. Some people are allergic to nickel and get rashes from cheap jewelry. Stainless steel contains nickel that prevents rusting and keeps kitchen sinks and medical instruments clean and bright. Nickel holds its shine through decades of use and never gives up. It is quiet but completely dependable. From nickel's lasting endurance, copper glows with warm, ancient beauty. Copper, the warm conductor. Copper glows with warm red-orange light and carries electricity better than almost any metal. With atomic number 29 and atomic mass 63.546, it conducts group 11, period 4. This soft, reddish metal bends easily and develops a green coating called patina when exposed to air and water. Copper melts at 1085 degrees Celsius and turns green-blue when it burns. The Statue of Liberty is made of copper that has turned green after more than 100 years. Fun fact: copper was the first metal humans learned to shape and use, starting the Copper Age over 7,000 years ago. Your body contains about 100 milligrams of copper. Every electrical wire in your house contains copper that carries power safely to lights and appliances. Ancient peoples made copper jewelry, tools, and coins that still exist today. Copper is the bridge between human history and modern technology. After copper's ancient wisdom, zinc arrives with protective power. Zinc, the silent protector. Zinc guards steel from rust by sacrificing itself to save other metals. With atomic number 30 and atomic mass 65.38, it protects group 12, period 4. This blue-white metal looks similar to magnesium but feels heavier and more substantial. Zinc melts at 420 degrees Celsius and burns with a bright blue-green flame. Galvanized steel is coated with zinc that prevents rusting for decades. Fun fact: zinc is essential for your immune system. Without enough zinc, you get sick more often and wounds heal slowly. Pennies made after 1982 are mostly zinc with a thin copper coating. Your body contains about 2 grams of zinc concentrated in your skin, hair, and eyes. Zinc oxide creates the white sunscreen that protects surfers and lifeguards from burning. It works silently in the background, always protecting, never asking for credit. From zinc's selfless shield, gallium flows with liquid surprises. Gallium, the hand melter. Gallium melts in your warm hand, transforming from solid metal to liquid mercury-like drops. With atomic number 31 and atomic mass 69.723, it surprises everyone in group 13, period 4. This silvery metal has the strange property of melting at only 30 degrees Celsius. Gallium stays liquid until it cools below 30 degrees, then slowly solidifies again. It expands when it freezes, just like water, which is very unusual for metals. Fun fact: gallium will melt if you hold it on a hot summer day or in your closed fist. It can make aluminum brittle just by touching it. Computer chips use gallium compounds that glow different colors when electricity passes through them, creating LED lights and laser pointers. Gallium reminds us that not all elements behave as we expect them to. After gallium's liquid surprise, germanium stands clear and bright like crystal. Germanium, the crystal thinker. Germanium shines like crystal and thinks like silicon in electronic devices. With atomic number 32 and atomic mass 72.64, it bridges group 14, period 4. This gray-white element looks like metal but acts like a semiconductor, conducting electricity only under special conditions. Germanium melts at 938 degrees Celsius and forms beautiful crystals that look like diamonds. It helps fiber optic cables carry internet signals around the world at light speed. Fun fact: germanium was predicted by Mendeleev 15 years before it was discovered. He called it DKA silicon and accurately predicted its properties. Infrared cameras use germanium lenses that can see heat in complete darkness, helping soldiers and firefighters see through smoke and shadows. Germanium is rare but essential for modern communications. From germanium's crystal clarity, arsenic whispers its double-edged story. Arsenic, the beautiful poison. Arsenic is both poison and medicine, beautiful and dangerous in the same breath. With atomic number 33 and atomic mass 74.922, it lurks in group 15, period 4. This steel gray element can appear as shiny metal or yellow powder, depending on how its atoms arrange themselves. Arsenic sublimes at 616 degrees Celsius, turning directly from solid to gas without melting. In tiny amounts, it treats certain diseases, but larger amounts cause sickness and death. Fun fact, arsenic has been called the poison of kings, because it was colorless, tasteless, and hard to detect in food. Victorian wallpaper contained arsenic that made beautiful green patterns but poisoned entire families. Some bacteria actually eat arsenic instead of phosphorus, showing that life finds ways to use even dangerous elements. Wood preservatives contain arsenic compounds that protect against insects and decay. It teaches respect for chemistry's double-edged power. After arsenic's warning, selenium captures light with gentle power. Selenium, the light catcher. Selenium captures sunlight and turns it into electricity in solar panels across the world. With atomic number 34 and atomic mass 78.96, it harvests light in group 16, period 4. This gray element can be shiny like metal or red like ruby, depending on its crystal structure. Selenium melts at 221 degrees Celsius and glows red when heated. It changes electrical conductivity when light shines on it, making it perfect for light sensors. Fun fact, selenium was discovered because it made the leftover sludge from sulfuric acid production bright red. Your body needs selenium to protect cells from damage, but too much can be harmful. Photocopiers use selenium drums that hold electrical charges in patterns of light and shadow, creating perfect copies of documents. Anti-dandruff shampoos contain selenium compounds that keep your scalp healthy. From selenium's light-gathering power, bromine flows like liquid fire. Bromine, the red liquid fire. Bromine is one of only 2 elements that is liquid at room temperature, flowing like red mercury. With atomic number 35 and atomic mass 79.904, it burns in group 17, period 4. This dark red liquid gives off orange-red vapors that smell sharp and dangerous. Bromine evaporates slowly at room temperature, filling closed containers with red-orange gas. It comes mainly from salt water and underground brines. Fun fact, bromine's name means stench in Greek because of its powerful, unpleasant smell. Ocean water contains bromine that gives it a faint bitter taste. Swimming pools often use bromine instead of chlorine because it works better in hot water and doesn't make your eyes sting. Flame retardants contain bromine compounds that prevent fires from spreading in furniture and electronics. Bromine stands between calm and chaos, useful but demanding respect. After bromine's liquid danger, krypton lights up with noble grace. Krypton, the hidden light. Krypton hides invisibly in air but glows with brilliant white light when electricity flows through it. With atomic number 36 and atomic mass 83.798, it illuminates group 18, period 4. This colorless, odorless noble gas makes up only 0.0001% of air. Krypton becomes liquid at minus 153 degrees Celsius, appearing colorless like water. High-intensity lamps use krypton gas that glows brighter than almost any other light source. Fun fact, krypton gets its name from the Greek word for hidden, because it was so hard to discover. Superman's home planet Krypton was named after this mysterious element. Airport runway lights and high-end flashlights use krypton bulbs that cut through fog and darkness with pure white brilliance. Krypton feels like a secret star captured on Earth, staying apart yet shining when called upon. From krypton's hidden glow, rubidium bursts with purple fire. Rubidium, the purple flame. Rubidium burns with the most beautiful purple flame, like liquid amethyst dancing in air. With atomic number 37 and atomic mass 85.468, it ignites group 1, period 5. This soft, silvery metal is so reactive it bursts into flames in ordinary air and explodes violently in water. Rubidium melts at only 39 degrees Celsius, becoming liquid on a hot summer day. It must be stored under oil to prevent it from reacting with moisture in air. Fun fact: rubidium was discovered by watching its purple flame through a spectroscope. Atomic clocks use rubidium to keep perfect time, losing only 1 second every 300,000 years. Your body contains about 360 milligrams of rubidium, though scientists are still learning what it does. GPS satellites use rubidium clocks to pinpoint your exact location anywhere on Earth. Rubidium is quick, restless, and full of fiery energy, like a spark that refuses to be contained. After rubidium's purple rush, strontium paints the night sky red. Strontium, the fireworks artist. Strontium creates the brilliant red explosions in fireworks that light up the 4th of July sky. With atomic number 38 and atomic mass 87.62, it celebrates in group 2, period 5. This soft, silvery metal burns with intense red light that photographers once used for color film. Strontium melts at 777 degrees Celsius and glows like hot coals when heated. It is found in the mineral celestite, which forms beautiful blue crystals. Fun fact: strontium salts were first discovered in a Scottish village called Strontian. Your bones and teeth contain small amounts of strontium that help keep them strong. Road flares burn strontium compounds to create bright red warning lights visible for miles. Deep-sea creatures near underwater volcanic vents use strontium in their shells and skeletons. Strontium brings both beauty in celebration and strength in protection. After strontium's red glory, yttrium adds hidden power to technology. Yttrium, the rare earth pioneer. Yttrium glows red in television screens and strengthens alloys that must survive extreme conditions. With atomic number 39 and atomic mass 88.906, it pioneers group 3, period 5. This silvery metal looks ordinary but possesses extraordinary powers in modern technology. Yttrium melts at 1526 degrees Celsius and becomes superconducting when cooled with liquid nitrogen. It was first discovered in a Swedish quarry near the village of Ytterby, which gave its name to 4 different elements. Fun fact: old color TV screens glowed red because of yttrium compounds mixed with europium. MRI machines use yttrium in superconducting magnets. Spark plugs in car engines contain yttrium that helps them fire reliably for hundreds of thousands of miles. Though hidden from daily sight, yttrium carries quiet importance in lasers, ceramics, and cancer treatments. After yttrium's technological strength, zirconium shines with nuclear power. Zirconium, the nuclear guardian. Zirconium stands guard in nuclear reactors, staying strong and safe even surrounded by deadly radiation. With atomic number 40 and atomic mass 91.224, it protects group 4, period 5. This gray-white metal resists corrosion better than stainless steel and never becomes brittle from radiation. Zirconium melts at 1855 degrees Celsius and burns with brilliant white light. Zircon gemstones contain zirconium and sparkle almost like diamonds. Fun fact: Zirconium is so resistant to corrosion that it's used in chemical plants that handle the most dangerous acids. Some of the oldest minerals on Earth are zircon crystals over 4 billion years old. Nuclear fuel rods are wrapped in zirconium tubes that contain radioactive material safely for decades. Artificial joints made from zirconium last longer in the human body than any other material. Zirconium is strength and beauty combined, holding calm even under the most extreme pressure. From zirconium's nuclear strength, niobium rises with superconducting promise. Niobium, the superconductor. Niobium carries electricity with zero resistance when cooled to super low temperatures, making it truly superconducting. With atomic number 41 and atomic mass 92.906, it flows through group 5, period 5. This gray metal bends without breaking and stays strong under enormous stress. Niobium melts at 2,477 degrees Celsius, one of the highest melting points of all elements. Jet engines use niobium alloys that stay strong even in the hottest flames. Fun fact: niobium superconducting magnets in MRI machines are cooled with liquid helium to -269 degrees Celsius. The Large Hadron Collider uses 1,200 tons of niobium in its superconducting magnets. Particle accelerators around the world depend on niobium magnets to guide beams of protons at nearly light speed. Body jewelry made from niobium never causes allergic reactions and keeps its color forever. It feels steady and calm, holding enormous strength in perfect balance. From niobium's superconducting power, molybdenum steps forward with heat resistance. Molybdenum, the heat shield. Molybdenum survives the hottest furnaces and strongest acids without melting or corroding. With atomic number 42 and atomic mass 95.96, it endures in group 6, period 5. This silver-gray metal has the 6th highest melting point of all elements and never gives up under stress. Molybdenum melts at 2,623 degrees Celsius, hot enough to melt most other metals. Steel containing molybdenum stays strong in jet engines and nuclear reactors. Fun fact: molybdenum's name comes from the Greek word for lead because early miners confused it with lead ore. Your body needs tiny amounts of molybdenum to process proteins properly. Oil refineries use molybdenum catalysts to remove sulfur from gasoline, making car exhaust cleaner. Armor-piercing shells contain molybdenum that helps them penetrate thick steel. Though often hidden, molybdenum keeps machines working in the most extreme conditions. From molybdenum's protective shield, technetium appears as humanity's first artificial element. Technetium, the man-made pioneer. Technetium was the first element created by humans rather than discovered in nature. With atomic number 43 and atomic mass 98, it glows artificially in group 7, period 5. This silvery metal is radioactive and exists only because scientists learned to build atoms in laboratories. Technetium melts at 2,157 degrees Celsius and glows faintly in the dark from its own radioactivity. It fills a gap in the periodic table that Mendeleev predicted would exist. Fun fact: technetium gets its name from the Greek word technetos, meaning artificial. Nuclear medicine uses technetium in 20 million medical scans each year to trace blood flow and organ function. Stars create technetium naturally in their nuclear furnaces, but it decays too quickly to survive on Earth without constant creation. Heart stress tests use technetium that shows doctors exactly how blood moves through cardiac muscles. Technetium is humanity's first man-made star, captured in laboratories and hospitals worldwide. After technetium's artificial glow, ruthenium shines with quiet durability. Ruthenium, the platinum helper. Ruthenium makes platinum jewelry harder and more beautiful while resisting wear and tarnish forever. With atomic number 44 and atomic mass 101.07, it assists group 8, period 5. This rare, silver-white metal belongs to the platinum family and costs more than gold. Ruthenium melts at 2,334 degrees Celsius and stays bright even in harsh chemicals. Computer hard drives use ruthenium layers that store digital information in magnetic patterns. Fun fact: ruthenium was the last platinum group metal to be discovered. Fountain pen tips contain ruthenium alloys that write smoothly for decades without wearing out. Solar panels use ruthenium compounds that convert sunlight to electricity more efficiently than silicon alone. Though rare and expensive, ruthenium works silently in technologies that define modern life. Its steady nature makes it a trusted ally in the most demanding applications. From ruthenium's reliable service, rhodium gleams with mirror perfection. Rhodium, the perfect mirror. Rhodium reflects light better than any other metal, creating mirrors so perfect they seem magical. With atomic number 45 and atomic mass 102.91, it reflects group 9, period 5. This brilliant white metal costs more than gold and platinum combined because of its incredible rarity and beauty. Rhodium melts at 1964 degrees Celsius and never tarnishes or corrodes, staying mirror bright forever. Luxury jewelry is plated with rhodium to achieve the most brilliant white shine possible. Fun fact: rhodium is so rare that all the rhodium ever mined would fit in a small room. Car catalytic converters use rhodium to clean exhaust gases and reduce pollution. High-end mirrors in telescopes and searchlights use rhodium coatings that reflect nearly 100% of visible light. White gold jewelry gets its brilliant color from rhodium plating that makes it more beautiful than pure platinum. Rhodium feels pure and untouchable, the ultimate expression of metallic perfection. After rhodium's perfect reflection, palladium absorbs hydrogen like a metallic sponge. Palladium, the hydrogen sponge. Palladium absorbs hydrogen gas like a sponge soaking up water, storing 900 times its own volume in hydrogen atoms. With atomic number 46 and atomic mass 106.42, it purifies group 10, period 5. This silvery white metal looks like platinum but costs much less. Palladium melts at 1,555 degrees Celsius and glows with soft white light when heated. Catalytic converters in cars use palladium to convert poisonous carbon monoxide into harmless carbon dioxide. Fun fact: palladium can absorb so much hydrogen it swells like a balloon and sometimes cracks from the pressure. Dental fillings contain palladium alloys that last for decades in your mouth. Electronics manufacturers use palladium in tiny components that must conduct electricity reliably for years. Hydrogen fuel cells use palladium catalysts that combine hydrogen and oxygen to make clean electricity. Palladium is rare and noble, a hidden hero working quietly to clean our air and power our future. From palladium's noble service, silver glows with ancient beauty. Silver, the liquid light. Silver reflects light and conducts electricity better than any other metal, flowing like liquid moonlight through wires and mirrors. With atomic number 47 and atomic mass 107.87, it shines in group 11, period 5. This brilliant white metal has been treasured by humans for over 5,000 years. Silver melts at 962 degrees Celsius and burns with a brilliant white flame. It kills bacteria naturally, which is why wealthy families once ate with silver utensils to avoid getting sick. Fun fact: silver tarnishes because it reacts with tiny amounts of sulfur in air, forming a thin black coating. Photography was invented using silver compounds that turn dark when exposed to light. Solar panels use silver paste that collects electricity from silicon cells and carries it to your home. Cloud seeding uses silver iodide crystals that help make rain during droughts. Silver carries both beauty and utility, bridging the gap between precious metal and essential technology. From silver's luminous history, cadmium enters with toxic beauty. Cadmium, the beautiful danger. Cadmium creates the most brilliant yellow and red pigments in art but hides deadly poison in its beauty. With atomic number 48 and atomic mass 112.41, it warns from group 12, period 5. This soft, blue-white metal looks innocent but requires careful handling. Cadmium melts at 321 degrees Celsius and burns with a reddish flame that releases toxic fumes. Artists' paints contain cadmium pigments that create colors so vibrant they seem to glow. Fun fact: cadmium yellow and cadmium red are among the most expensive and beautiful colors in oil painting. Van Gogh's sunflowers contain cadmium yellow that still blazes with color after 130 years. Rechargeable batteries once used cadmium, but newer batteries avoid it because of health concerns. Nuclear reactors use cadmium control rods that absorb neutrons and stop nuclear reactions instantly. Cadmium reminds us that the most beautiful things in chemistry often carry hidden dangers. After cadmium's toxic warning, indium melts with gentle touch. Indium, the soft touch. Indium is so soft it melts almost in your warm hand and can be scratched with a fingernail. With atomic number 49 and atomic mass 114.82, it touches group 13, period 5. This silvery metal is softer than lead and makes a crying sound when bent. Indium melts at only 157 degrees Celsius and stays liquid until it cools to room temperature. Touch screens on phones and tablets use invisible indium coatings that conduct electricity when you touch them. Fun fact: indium is rarer than silver but essential for modern electronics. When you bend a piece of indium, it makes a distinctive crying or squeaking sound. LCD screens in televisions and computer monitors use indium tin oxide that's completely transparent but conducts electricity perfectly. Dental mirrors contain indium that makes them fog resistant. Indium whispers modern comfort, hidden in devices you touch every day but never see. From indium's gentle softness, tin steps forward with ancient versatility. Tin, the bronze maker. Tin mixed with copper created bronze 5,000 years ago, launching human civilization into the Bronze Age. With atomic number 50 and atomic mass 118.71, it builds group 14, period 5. This silvery white metal bends easily and makes a distinctive crackling sound called tin cry when bent. Tin melts at 232 degrees Celsius and forms a protective oxide coating that prevents further corrosion. Food cans are made of steel coated with tin that keeps food safe for years. Fun fact: pure tin buttons on Napoleon's army uniforms crumbled in the Russian winter, turning to gray powder in a process called tin pest. Pewter contains mostly tin mixed with other metals. Tin soldiers, tin whistles, and tin foil were common before aluminum became cheap and popular. Bronze bells and statues contain tin that gives bronze its beautiful golden color and clear ringing sound. Tin is humble but enduring, serving humanity faithfully across millennia of history. From tin's ancient wisdom, antimony adds fire-resistant mystery. Antimony, the fire fighter. Antimony protects fabrics and plastics from catching fire, adding flame-resistant power to everything from children's pajamas to airplane seats. With atomic number 51 and atomic mass 121.76, it guards group 15, period 5. This brittle, silver-white metal breaks like glass but fights fire like a champion. Antimony melts at 631 degrees Celsius and burns with a pale blue flame. Ancient Egyptians used antimony powder as black eye makeup that also protected against eye infections. Fun fact, antimony expands when it solidifies, just like water turning to ice. This property made it perfect for casting sharp, detailed type for printing presses. Bullet manufacturers add antimony to lead to make harder, more accurate projectiles. Flame retardants in electronics and furniture contain antimony compounds that release gases that smother flames. Antimony balances usefulness with danger, protecting us from fire while demanding respect for its toxic properties. After antimony's protective mystery, tellurium whispers with semiconductor secrets. Tellurium, the semiconductor whisperer. Tellurium transforms sunlight into electricity in advanced solar panels and makes some of the most efficient thermoelectric devices ever created. With atomic number 52 and atomic mass 127.60, it conducts group 16, period 5. This silvery white metalloid smells like garlic when heated. Tellurium melts at 450 degrees Celsius and glows with greenish light when heated in air. It is one of the rarest stable elements on Earth, even rarer than gold. Fun fact, eating tellurium compounds makes your breath smell like garlic for weeks because your body cannot break them down easily. Rewritable CDs and DVDs use tellurium alloys that change between crystalline and amorphous states. Thermoelectric coolers in wine fridges and portable refrigerators use bismuth telluride that pumps heat without any moving parts. Some of the most efficient solar panels ever made use cadmium telluride that converts sunlight to electricity better than silicon. From tellurium's electronic whispers, iodine glows purple with healing power. Iodine, the purple healer. Iodine glows with beautiful purple vapors when heated and keeps your thyroid gland healthy throughout your life. With atomic number 53 and atomic mass 126.90, it heals in group 17, period 5. This dark gray solid turns to purple gas without ever becoming liquid under normal conditions. Iodine sublimes at 184 degrees Celsius, creating purple vapors that smell sharp and medicinal. Tincture of iodine was the most common antiseptic for over 100 years. Fun fact, iodine gets its name from the Greek word for violet because of its beautiful purple vapor. Iodized salt contains tiny amounts of iodine that prevent goiter, a swelling of the thyroid gland. Your thyroid gland concentrates iodine from your bloodstream and uses it to make hormones that control your metabolism. X-ray contrast agents contain iodine compounds that make organs visible in medical scans. Iodine is a gentle guardian of health, protecting millions from thyroid disease. From iodine's purple protection, xenon shines with noble brilliance. Xenon, the bright noble. Xenon produces the brightest white light of any gas and powers the most intense lamps ever created. With atomic number 54 and atomic mass 131.29, it illuminates group 18, period 5. This colorless, odorless noble gas is so rare it makes up only 0.000009% of Earth's atmosphere. Xenon becomes liquid at -108 degrees Celsius and glows brilliant blue-white when electricity passes through it. High-intensity discharge lamps use xenon to create light brighter than the sun. Fun fact: xenon was discovered in 1898 as the leftover gas after krypton was removed from liquid air. Movie theater projectors use xenon bulbs that can light up screens 100 feet wide. Car headlights use xenon gas that produces light twice as bright as regular bulbs while using less energy. Ion drives on spacecraft use xenon gas as fuel, pushing against individual atoms to propel satellites through space. Xenon feels otherworldly and powerful, like a piece of distant starlight captured on Earth. From xenon's brilliant illumination, cesium rushes forward with atomic precision. Cesium, the perfect timekeeper. Cesium keeps the most accurate time in the universe, defining the official length of 1 second with atomic precision. With atomic number 55 and atomic mass 132.91, it measures group 1, period 6. This soft, golden metal is so reactive it explodes violently in water and catches fire in ordinary air. Cesium melts at only 28 degrees Celsius, becoming liquid in your warm hand. Atomic clocks use cesium atoms that vibrate exactly 9,192,631,770 times per second. Fun fact: cesium was discovered by its golden flame color in a spectroscope. GPS satellites use cesium clocks to pinpoint your location to within 3 feet anywhere on Earth. Cesium compounds are used to remove the last traces of oxygen from vacuum tubes in electronics. Photoelectric cells use cesium that releases electrons when light hits it, converting light directly into electricity. Cesium is restless and energetic but incredibly precise, measuring the heartbeat of time itself. After cesium's golden precision, barium lights up medical pathways. Barium, the medical tracer. Barium glows green in fireworks and lights up your digestive system in X-ray photographs. With atomic number 56 and atomic mass 137.33, it traces group 2, period 6. This soft, silvery metal burns with brilliant green flame and helps doctors see inside your body. Barium melts at 727 degrees Celsius and reacts slowly with water, releasing hydrogen gas. Barium sulfate is completely safe to drink and blocks X-rays, making your stomach and intestines visible to doctors. Fun fact: barium compounds create the beautiful green colors in fireworks displays worldwide. Drilling mud contains barium that makes oil wells heavier and safer to drill. CT scans and X-rays use barium contrast that shows the exact shape of your digestive organs without any surgery. Green signal flares contain barium that burns with brilliant emerald light visible for miles. Barium combines beauty with medical necessity, lighting paths both in the sky and inside your body. From barium's diagnostic glow, lanthanum opens the gateway to rare earth treasures. Lanthanum, the rare earth gateway. Lanthanum opens the mysterious series of rare earth elements, each one more special than the last. With atomic number 57 and atomic mass 138.91, it guards group 3, period 6, beginning the lanthanide series. This soft, silvery metal tarnishes rapidly in air but holds the key to modern technology. Lanthanum melts at 920 degrees Celsius and glows with white light when heated. Camera lenses use lanthanum glass that focuses light more precisely than ordinary glass. Fun fact, lanthanum gets its name from the Greek word meaning, to lie hidden, because it was so difficult to separate from other rare earth elements. Hybrid car batteries contain lanthanum in their nickel metal hydride cells. Stage lighting and movie projectors use carbon arc lamps with lanthanum electrodes that create the whitest, most natural light possible. Catalysts in oil refineries use lanthanum to crack petroleum into gasoline more efficiently. Lanthanum feels like a gatekeeper to hidden technological treasures, beginning a journey through elements that power our modern world. From lanthanum's gateway, cerium sparks with fiery light. Cerium, the fire starter. Cerium creates the sparks in cigarette lighters and camping lighters that ignite with every strike. With atomic number 58 and atomic mass 140.12, it ignites the lanthanide series with fire. This gray metal is the most abundant of all rare earth elements but still more rare than copper. Cerium melts at 795 degrees Celsius and burns with brilliant white sparks when scraped or struck. Ferrocerium in lighter flints contains cerium that creates reliable sparks in all weather conditions. Fun fact, cerium is pyrophoric, meaning it catches fire spontaneously when scratched or filed. Self-cleaning ovens use cerium compounds that help break down grease and food residue. Glass polishing uses cerium oxide powder that removes scratches from telescope mirrors and camera lenses with atomic precision. Catalytic converters in cars contain cerium that helps burn fuel more completely and reduces pollution. Cerium teaches us that common things can carry the power of fire itself. After cerium's reliable spark, praseodymium glows with gentle green light. Praseodymium, the green painter. Praseodymium creates the most beautiful green colors in glass and ceramics, painting the world with emerald light. With atomic number 59 and atomic mass 140.91, it colors the rare earth series. This silvery metal develops a slow green tarnish in air that protects it from further oxidation. Praseodymium melts at 931 degrees Celsius and burns with a greenish-white flame. Welding goggles use praseodymium glass that filters out dangerous yellow light while letting safe colors through. Fun fact, praseodymium's name means green twin in Greek because it was first confused with neodymium. Airport runway lights use praseodymium that shows pilots exactly where to land in fog and darkness. Powerful magnets combine praseodymium with neodymium to create the strongest permanent magnets ever made. Carbon arc searchlights use praseodymium electrodes that cut through fog and smoke with brilliant green beams. Praseodymium adds harmony and color to both technology and art. From its gentle green glow, neodymium sings with magnetic power. Neodymium, the magnetic maestro. Neodymium creates the strongest permanent magnets in the universe, powering everything from headphones to wind turbines. With atomic number 60 and atomic mass 144.24, it magnetizes the rare earth series. This silvery metal forms magnets so powerful they can crush fingers if handled carelessly. Neodymium melts at 1024 degrees Celsius and glows with brilliant white light when heated. Neodymium magnets are 10 times stronger than ordinary iron magnets of the same size. Fun fact: neodymium magnets can maintain their strength for hundreds of years without losing power. Electric car motors use neodymium magnets that convert electricity to motion with incredible efficiency. Hard disk drives in computers use neodymium magnets to read and write data at lightning speed. Magnetic resonance imaging machines use neodymium in superconducting magnets that see inside your body without X-rays. Neodymium carries invisible forces that power the modern world through magnetic fields. From neodymium's magnetic song, promethium glows with artificial rarity. Promethium, the Prometheus element. Promethium glows faintly in the dark with its own radioactive light, like stealing fire from the gods. With atomic number 61 and atomic mass S145, it radiates through the rare earth series. This silvery metal exists only because humans learned to create it in nuclear reactors. Promethium melts at 1042 degrees Celsius and emits soft blue-green light from its radioactivity. Nuclear batteries use promethium that glows for years without any external power source. Fun fact: promethium is named after Prometheus, who stole fire from the gods and gave it to humans. It was the last rare earth element to be discovered because it doesn't exist naturally on Earth. Glow-in-the-dark watches once used promethium paint that needed no charging from sunlight or artificial light. Spacecraft used promethium batteries that work reliably in the cold darkness of space for decades. Promethium feels mysterious and fleeting, like captured starlight that slowly fades back to darkness. From its brief nuclear glow, samarium steadies the story with magnetic strength. Samarium, the cancer fighter. Samarium fights cancer with targeted radiation therapy and creates magnets that work at high temperatures. With atomic number 62 and atomic mass 150.36, it heals through the rare earth series. This silvery metal stays magnetic even when heated red hot, unlike iron magnets that lose their power. Samarium melts at 1072 degrees Celsius and glows with orange light when heated in air. Samarium cobalt magnets work perfectly in jet engines where temperatures would destroy neodymium magnets. Fun fact: radioactive samarium 153 is injected directly into bone cancer tumors, where it delivers healing radiation precisely where needed. Guitar pickups use samarium magnets that capture string vibrations with perfect clarity. Headphones and speakers use samarium magnets that reproduce music with incredible fidelity across all frequencies. Nuclear medicine uses samarium isotopes that treat bone pain in cancer patients while sparing healthy tissue. Though rare, samarium serves humanity greatly in both technology and healing. From samarium's therapeutic service, europium glows with television light. Europium, the red screen glow. Europium makes television and computer screens glow with pure red light that's perfectly matched to human vision. With atomic number 63 and atomic mass 151.96, it illuminates the rare earth series. This silvery metal is the most reactive of all rare earth elements. Europium melts at 822 degrees Celsius and glows brilliant red when heated or excited by electricity. Old color television sets used europium compounds that created the red pixels in every image. Fun fact: europium is named after Europe and is the only element named after a continent. Euro banknotes contain europium compounds that glow under ultraviolet light to prevent counterfeiting. LED lights use europium that converts blue light to red light with perfect efficiency and beautiful color. Fluorescent lamps contain europium phosphors that make artificial light look more like natural sunlight. Europium adds beauty and authenticity to the artificial light that brightens our modern world. From europium's television glow, gadolinium strengthens medical imaging. Gadolinium, the MRI helper. Gadolinium makes MRI scans clearer and safer, helping doctors see inside your body with incredible detail. With atomic number 64 and atomic mass 157.25, it magnetizes medical science. This silvery metal becomes magnetic when cooled and loses its magnetism when heated, unlike most magnetic materials. Gadolinium melts at 1313 degrees Celsius and has the highest magnetic moment of any element. MRI contrast agents contain gadolinium that makes soft tissues show up clearly in magnetic images. Fun fact, gadolinium was named after Finnish chemist Johann Gadolin, who first studied rare earth minerals. It becomes non-magnetic above 20 degrees Celsius, making it useful in magnetic refrigeration. Nuclear reactors use gadolinium control rods that absorb neutrons more effectively than any other element. Magnetic cooling systems use gadolinium that becomes hot when magnetized and cool when demagnetized. Though hidden from daily life, gadolinium plays a key role in both healing and nuclear safety. From gadolinium's magnetic medicine, terbium glows with green laser light. Terbium, the green laser. Terbium creates the greenest laser light possible and makes computer screens glow with perfect color. With atomic number 65 and atomic mass 158.93, it beams through the rare earth series. This silvery metal glows brilliant green when electricity passes through its compounds. Terbium melts at 1356 degrees Celsius and burns with brilliant yellow-green flame. Solid-state lasers use terbium that produces intense green light for medical surgery and scientific research. Fun fact, terbium was named after the Swedish village of Ytterby, which gave its name to 4 different rare earth elements. Magneto-optical drives use terbium alloys that store data using magnetic and optical properties together. Green phosphors in fluorescent lamps contain terbium that makes artificial light look more natural and pleasant. Aircraft navigation lights use terbium compounds that create the precise green color required by aviation regulations. Terbium adds perfect color and laser precision to technology that demands the highest quality light. From terbium's green precision, dysprosium offers strength under extreme stress. Dysprosium, the stress survivor. Dysprosium creates magnets that stay strong even in the most extreme heat and stress conditions. With atomic number 66 and atomic mass 162.50, it endures through the rare earth series. This silvery metal never gives up its magnetic properties, even in temperatures that would melt steel. Dysprosium melts at 1412 degrees Celsius and glows with brilliant white light when heated. Wind turbine generators use dysprosium magnets that work perfectly in freezing Arctic winds and blazing desert heat. Fun fact: dysprosium's name means hard to get in Greek because it was extremely difficult to isolate from other rare earth elements. It is one of the most expensive elements on Earth. Hybrid car motors contain dysprosium magnets that deliver maximum power while staying cool and reliable for hundreds of thousands of miles. Nuclear reactors use dysprosium in control rods that absorb neutrons safely at extremely high temperatures. Though rare and costly, dysprosium is essential for green energy systems that must work in the harshest conditions. From its resilient strength, holmium whispers with maximum magnetism. Holmium, the magnetic champion. Holmium possesses the strongest magnetic properties of any element in the universe, bending magnetic fields with quiet force. With atomic number 67 and atomic mass 164.93, it magnetizes the rare earth series with maximum power. This silvery metal concentrates magnetic energy like no other element can. Holmium melts at 1474 degrees Celsius and glows with bright yellow light when heated. Superconducting magnets use holmium alloys that create the strongest magnetic fields ever achieved. Fun fact: holmium is named after Stockholm, Sweden, Holmia in Latin. Magnetic flux concentrators use holmium to focus magnetic fields into tiny spaces for precision manufacturing. Laser surgery uses holmium lasers that cut through tissue with incredible precision while sealing blood vessels instantly. Though rare and hidden in specialized applications, holmium represents the ultimate expression of magnetic force in the periodic table. From holmium's magnetic mastery, erbium carries light across the world. Erbium, the Internet carrier. Erbium amplifies light signals that carry Internet data around the world through fiber optic cables. With atomic number 68 and atomic mass 167.26, it connects the rare earth series to global communication. This silvery metal makes the Internet possible by boosting light signals across vast distances. Erbium melts at 1529 degrees Celsius and glows with beautiful pink light in glass and crystals. Fiber optic amplifiers use erbium that takes weak light signals and makes them strong enough to travel thousands of miles underwater. Fun fact: erbium-doped fiber amplifiers make the global Internet possible by boosting light signals every 50 miles in undersea cables. Pink glass containing erbium filters infrared light in welding goggles and camera lenses. Laser eye surgery uses erbium lasers that reshape corneas with incredible precision, correcting vision in minutes. Every email, video call, and streaming movie travels through erbium amplifiers that keep digital light signals bright and clear. Erbium is calm, steady, and bright, hidden in the invisible flow of modern communication. After erbium's global connections, thulium glows with precious rarity. Thulium, the rarest treasure. Thulium is the rarest and most expensive of all rare earth elements, more precious than gold or platinum. With atomic number 69 and atomic mass 168.93, it treasures the rare earth series with ultimate scarcity. This silvery metal is so rare that all the thulium ever refined would fit in a small closet. Thulium melts at 1545 degrees Celsius and glows with brilliant blue-white light when heated. Portable X-ray machines use thulium isotopes that create medical images without needing electrical power. Fun fact: thulium is 200 times rarer than gold and costs more than most precious metals. It was the last rare earth element to be isolated in pure form. Cancer treatment uses thulium-170 in targeted radiation therapy that destroys tumors while sparing healthy tissue. High-temperature superconductors use thulium compounds that conduct electricity with zero resistance when cooled. Thulium feels precious and gentle, whispering of quiet importance despite its incredible rarity. From thulium's treasured scarcity, ytterbium follows with precise timekeeping. Ytterbium, the timekeeper. Ytterbium creates the most accurate atomic clocks ever built, measuring time more precisely than the rotation of the Earth. With atomic number 70 and atomic mass 173.04, it times the rare Earth series with perfect precision. This soft, silvery metal completes the lanthanide journey with clockwork accuracy. Ytterbium melts at 824 degrees Celsius and glows with green light when heated. Atomic clocks use ytterbium atoms that vibrate 518 trillion times per second with perfect regularity. Fun fact: ytterbium atomic clocks are so accurate they would lose less than 1 second if they ran for 15 billion years. Stress gauges use ytterbium that changes electrical resistance under pressure. Quantum computers use ytterbium ions trapped in laser light to perform calculations impossible for ordinary computers. GPS satellites may soon use ytterbium clocks that pinpoint locations with even greater accuracy than current technology allows. Ytterbium feels like a gentle rhythm in science, steady and smooth as time itself. After ytterbium's precise timing, lutetium arrives with elegant completion. Lutetium, the elegant finale. Lutetium completes the lanthanide series with quiet elegance and dignity, the last and most expensive of the rare earth elements. With atomic number 71 and atomic mass 174.97, it concludes Group 3, Period 6 with refined grace. This silvery white metal is harder than most other lanthanides and incredibly resistant to corrosion. Lutetium melts at 1663 degrees Celsius, the highest melting point of all lanthanides, and glows with brilliant white light. PET scans use lutetium detectors that find cancer cells hiding anywhere in the human body. Fun fact: lutetium is the most expensive of all rare earth elements, costing more than $10,000 per kilogram. It was the last naturally occurring rare earth element to be discovered. Medical imaging uses lutetium oxyorthosilicate crystals that detect gamma rays with perfect precision, saving lives through early cancer detection. High refractive index glass contains lutetium that focuses light more precisely than ordinary optical glass. Lutetium is precise, graceful, and dignified, ending the lanthanide story with scientific elegance. From lutetium's refined conclusion, hafnium steps forward with nuclear fire resistance. Hafnium, the nuclear fire guard. Hafnium stands guard in nuclear reactors, absorbing neutrons and controlling atomic fire with unmatched reliability. With atomic number 72 and atomic mass 178.49, it guards Group 4, Period 6 with nuclear strength. This steel gray metal resists corrosion better than stainless steel and never fails under radiation. Hafnium melts at 2233 degrees Celsius and burns with brilliant orange sparks when ignited. Nuclear submarines use hafnium control rods that regulate nuclear reactions with split-second precision. Fun fact: hafnium is almost identical to zirconium chemically but absorbs neutrons 600 times better, making it essential for nuclear safety. It was predicted by Mendeleev but not discovered until 1923. Computer processors use hafnium compounds in transistors smaller than viruses, switching billions of times per second without wearing out. Plasma torches use hafnium electrodes that cut through steel like butter while staying sharp for thousands of cuts. Hafnium feels like a guardian of atomic flame, powerful yet completely controlled. From hafnium's nuclear protection, tantalum brings eternal endurance. Tantalum, the eternal metal. Tantalum resists every acid, base, and corrosive chemical known to science, lasting forever without degradation. With atomic number 73 and atomic mass 180.95, it endures in group 5, period 6 with legendary patience. This dark gray metal never gives in to corrosion, even in the most hostile environments. Tantalum melts at 3017 degrees Celsius, the fifth highest melting point of all elements, and glows like a blue star when heated. Smartphones use tantalum capacitors that store electrical energy in incredibly small spaces. Fun fact: tantalum is named after Tantalus from Greek mythology, who was punished to eternal thirst because early chemists couldn't make tantalum react with acids. Hip and knee replacements use tantalum that integrates perfectly with human bone. Chemical plants use tantalum equipment that handles the most corrosive acids without any protection or maintenance for decades. Surgical instruments made from tantalum never corrode in the human body and cause no allergic reactions. Tantalum is patient, enduring, and eternal, outlasting almost everything else in the universe. After tantalum's timeless patience, tungsten burns with the hottest intensity. Tungsten, the unbreakable fire. Tungsten has the highest melting point of any metal, glowing white-hot at temperatures that would vaporize steel. With atomic number 74 and atomic mass 183.84, it burns through group 6, period 6 with unstoppable intensity. This gray metal is twice as dense as lead and harder than many ceramics. Tungsten melts at 3695 degrees Celsius, hot enough to melt almost any other substance on Earth, and never softens under extreme heat. Incandescent light bulbs use tungsten filaments that glow white-hot for thousands of hours without burning up. Fun fact: tungsten's name means heavy stone in Swedish because its ores are incredibly dense. A tungsten cube the size of a golf ball weighs as much as a baseball made of lead. Armor-piercing bullets use tungsten cores that penetrate steel tanks like needles through cloth. TIG welding electrodes are made of tungsten that never melts, even in the hottest welding flames. Tungsten feels unshakable and eternal, like crystallized starfire captured in metal form. From tungsten's blazing intensity, rhenium follows with space-age rarity. Rhenium, the rocket metal. Rhenium powers rocket engines and jet turbines, staying strong in the hottest flames ever created by humans. With atomic number 75 and atomic mass 186.21, it rockets through group 7, period 6 with aerospace strength. This silvery white metal is one of the rarest elements on Earth, more scarce than gold or platinum. Rhenium melts at 3186 degrees Celsius and maintains its strength at temperatures that would melt most other metals. Jet engine turbine blades use rhenium superalloys that spin at 10,000 rpm in flames hot enough to melt copper. Fun fact: rhenium was the last stable element to be discovered, found in 1925. All the rhenium ever produced would fit in a small room. Spacecraft thrusters use rhenium that resists the extreme heat and chemical stress of rocket fuel combustion. Catalysts in oil refineries use rhenium to produce high-octane gasoline more efficiently than any other element. Rhenium is hidden but mighty, a space-age treasure locked in earthly stone. From rhenium's rocket power, osmium arrives with maximum density. Osmium, the densest element. Osmium is the densest substance in the universe, packing more matter into each cubic inch than any other element. With atomic number 76 and atomic mass 190.23, it compresses group 8, period 6 with maximum density. This blue-gray metal feels impossibly heavy and hard, like compressed starlight. Osmium melts at 3033 degrees Celsius and glows with a distinctive blue-white light when heated. A cube of osmium the size of a sugar cube weighs as much as a baseball. Fun fact: osmium is twice as dense as lead and slightly denser than iridium, making it the heaviest element by volume. Its name comes from the Greek word for smell, because osmium tetroxide has a strong odor. Fountain pen nibs use osmium alloys that write smoothly for decades without wearing away. Electrical contacts use osmium that never corrodes or wears out, even after millions of switching cycles. Osmium is weight and permanence in pure form, eternal and impossibly heavy. From osmium's crushing density, iridium sparks with cosmic history. Iridium, the asteroid metal. Iridium came to Earth in asteroids and marks the moment when dinosaurs vanished 66 million years ago. With atomic number 77 and atomic mass 192.22, it crashes through group 9, period 6 with cosmic force. This silvery white metal is the second densest element and the most corrosion-resistant substance known. Iridium melts at 2466 degrees Celsius and burns with brilliant white light that never dims or tarnishes. The asteroid that killed the dinosaurs left a thin layer of iridium in rock formations worldwide. Fun fact: iridium is 40 times rarer in Earth's crust than gold because most of it sank to the core when Earth was molten. Spark plugs in racing cars use iridium electrodes that fire reliably for 100,000 miles. Standard meter bars were once made of platinum-iridium alloy that defined the exact length of 1 meter for over 100 years. X-ray tubes use iridium that produces the sharpest medical images while lasting for thousands of scans. Iridium is cosmic and timeless, carrying the memory of catastrophic impacts from space. From iridium's stellar story, platinum shines with noble perfection. Platinum, the noble perfection. Platinum never tarnishes, rusts, or fades, staying beautiful and pure forever like captured moonlight. With atomic number 78 and atomic mass 195.08, it perfects group 10, period 6 with noble grace. This silvery white metal is 30 times rarer than gold and completely resistant to corrosion. Platinum melts at 1768 degrees Celsius and glows with pure white light when heated. Wedding rings made of platinum last for generations without showing any signs of wear or tarnish. Fun fact: platinum is so unreactive that it was once called "little silver" by Spanish conquistadors who threw it away as worthless. Louis XVI of France declared platinum the only metal fit for royalty. Catalytic converters use platinum to clean car exhaust, removing harmful pollutants and saving millions of lives from air pollution. Chemotherapy drugs use platinum compounds that target cancer cells with precision while sparing healthy tissues. UE. Platinum feels pure and untouchable, the ultimate expression of noble metal perfection. From platinum's eternal nobility, gold glows with human dreams. #Gold, the dream metal. Gold has captured human hearts and dreams for 6,000 years, never losing its warm, sunny glow or magical appeal. With atomic number 79 and atomic mass 196.97, it treasures group 11, period 6 with eternal beauty. This soft, yellow metal never rusts, tarnishes, or fades, staying perfect forever. Gold melts at 1064 degrees Celsius and glows like liquid sunshine when heated. A single ounce of gold can be beaten into a sheet thin enough to cover a football field. Fun fact, all the gold ever mined in human history would fit in a cube only 70 feet on each side. Gold conducts electricity better than almost any other metal except silver and copper. Electronic devices use gold contacts and circuits that never corrode, ensuring perfect connections for decades. Ancient Egyptian gold jewelry buried 4,000 years ago still shines as brightly as the day it was made. Gold is wealth, beauty, and human aspiration made metal, eternal in both form and meaning. After gold's immortal glow, mercury flows as liquid mystery. #Mercury, the liquid metal. Mercury flows like silver water at room temperature, the only metal that is liquid without heating. With atomic number 80 and atomic mass 200.59, it flows through group 12, period 6 with liquid grace. This bright, silvery metal forms perfect spheres that roll like ball bearings and reflect light like mirrors. Mercury freezes at -39 degrees Celsius and boils at 357 degrees Celsius, remaining liquid across a huge temperature range. Old thermometers used mercury that expanded and contracted smoothly with temperature changes. Fun fact, Mercury gets its name from the Roman messenger god because it moves so quickly. It forms alloys called amalgams with almost every other metal except iron. Fluorescent lights contain tiny amounts of mercury vapor that glows blue-white when electricity passes through it. Mercury is both fascinating and dangerous, requiring careful handling because its vapors can harm the nervous system. It feels like liquid metal magic, always moving and never staying still. From Mercury's liquid dance, thallium whispers its toxic warning. #Thallium, the poisonous pretender. Thallium looks innocent and harmless but hides deadly poison in its soft, gray appearance. With atomic number 81 and atomic mass 204.38, it deceives in group 13, period 6. This heavy metal feels as soft as lead but carries dangers that demand extreme caution and respect. Thallium melts at 304 degrees Celsius and burns with a bright green flame that betrays its toxic nature. It was once used in rat poison and insecticides but proved too dangerous for general use. Fun fact, thallium was discovered by its brilliant green flame color in a spectroscope. It mimics potassium in the human body, which makes it especially toxic and hard to treat. Infrared detectors use thallium compounds that sense heat radiation with incredible sensitivity, helping night vision equipment see in complete darkness. Superconducting electronics use thallium compounds that conduct electricity with zero resistance at high temperatures. Thallium reminds us that every element has two faces, useful and dangerous depending on how we approach it. From thallium's deceptive warning, lead steps forward with heavy history. #Lead, the heavy protector. Lead is heavy, soft, and ancient, protecting humanity from radiation while teaching hard lessons about toxicity. With atomic number 82 and atomic mass 207.2, it weighs down group 14, period 6 with historical burden. This dull gray metal bends easily but carries the weight of human mistakes and wisdom. Lead melts at 327 degrees Celsius and forms a protective oxide coating that prevents further corrosion. X-ray technicians wear lead aprons that block harmful radiation, protecting patients and medical workers. Fun fact, lead was used in paint, pipes, and gasoline for decades before scientists understood its dangers to human health. The phrase, "getting the lead out," comes from removing lead additives from gasoline. Nuclear power plants use lead shielding that stops the most dangerous radiation without becoming radioactive itself. Car batteries contain lead plates that store electrical energy reliably for years in all weather conditions. Lead carries the weight of past mistakes while teaching us to use science more wisely. From lead's heavy lessons, bismuth shines with rainbow beauty. #Bismuth, the rainbow crystal. Bismuth forms the most beautiful crystals in the periodic table, growing in rainbow-colored steps like metallic staircases to heaven. With atomic number 83 and atomic mass 208.98, it crystallizes group 15, period 6 with geometric beauty. This silvery white metal creates art from chemistry when it cools and solidifies. Bismuth melts at only 271 degrees Celsius and expands when it solidifies, creating crystal formations with incredible geometric patterns. It is the most diamagnetic element, repelling magnetic fields more strongly than any other substance. Fun fact: bismuth crystals form natural spiral staircases with edges that reflect light in rainbow colors. It is safer than most heavy metals and is used in stomach medicines like Pepto-Bismol. Cosmetics use bismuth compounds that create pearlescent colors in lipstick and eyeshadow without toxic effects. Low-melting alloys contain bismuth that liquefies in hot water, making them perfect for automatic fire sprinkler systems. Bismuth shows that beauty and safety can coexist in chemistry's palette. After bismuth's crystalline art, polonium glows with radioactive mystery. Polonium, the glowing danger. Polonium glows softly in the dark with its own radioactive light, discovered by Marie Curie in her quest to understand radiation. With atomic number 84 and atomic mass 209, it radiates through group 16, period 6 with dangerous beauty. This rare, silvery metal is so radioactive it glows blue-green and feels warm to the touch. Polonium melts at 254 degrees Celsius and sublimes easily, creating radioactive vapors that require extreme safety precautions. A piece of polonium the size of a grain of sand contains enough radioactivity to kill a person. Fun fact: polonium was the first element discovered through radioactivity and was named after Poland, Marie Curie's homeland. It generates so much heat from radioactive decay that it glows and stays warm without any external energy. Space heaters on satellites use polonium that generates steady heat from radioactive decay for months without batteries or solar panels. Anti-static brushes once used polonium to neutralize electrical charges, but safer alternatives replaced it. Polonium feels like captured starlight, beautiful but too dangerous to hold. From polonium's radioactive glow, astatine flickers with impossible rarity. Astatine, the vanishing element. Astatine is the rarest naturally occurring element on Earth, so scarce that only a few atoms exist at any moment. With atomic number 85 and atomic mass 210, it vanishes from group 17, period 6 with ultimate scarcity. This mysterious halogen appears and disappears so quickly that scientists can barely study it. Astatine would melt at about 302 degrees Celsius if enough could be collected, but it decays too quickly to form visible amounts. The entire Earth contains less than 1 ounce of astatine at any given time. Fun fact: astatine's name means unstable in Greek because it exists for only seconds before decaying into other elements. No one has ever seen what astatine looks like because there has never been enough to see. Cancer research uses astatine isotopes in experimental radiation therapy that targets tumors with incredible precision. All the astatine that has ever existed naturally on Earth would weigh less than a snowflake. Astatine feels like a fleeting shadow in chemistry, more idea than substance. From astatine's phantom existence, radon seeps with silent danger. Radon, the invisible threat. Radon seeps invisibly from the ground, a heavy radioactive gas that accumulates in basements and poses hidden health risks. With atomic number 86 and atomic mass 222, it settles in group 18, period 6 with weighty silence. This colorless, odorless noble gas is the heaviest of all gases and slowly decays with deadly radiation. Radon condenses to liquid at -62 degrees Celsius and glows with phosphorescent light from its own radioactivity. It rises from uranium deposits deep underground and can concentrate in poorly ventilated buildings. Fun fact, radon is the second leading cause of lung cancer after smoking, responsible for thousands of deaths each year from indoor air pollution. It was discovered in 1900 as radium emanation. Home detectors measure radon levels that can accumulate to dangerous concentrations in basements and lower floors. Radon mitigation systems use fans and pipes to prevent radioactive gas from entering homes and schools. Radon reminds us that invisible dangers require constant vigilance and scientific understanding. From radon's silent threat, francium flashes with ultimate reactivity. Francium, the ultimate metal. Francium is the most reactive metal in the universe, exploding instantly in air and water with uncontainable energy. With atomic number 87 and atomic mass 223, it flashes through group 1, period 7 with impossible reactivity. This radioactive alkali metal exists for only seconds before decaying into other elements. Francium would melt at about 27 degrees Celsius if it could exist long enough, becoming liquid at room temperature like cesium. Only a few atoms of francium exist on Earth at any moment, making it incredibly rare and short-lived. Fun fact, francium was predicted to exist before it was discovered and was found by analyzing the radioactive decay of other elements. It would react so violently with water that the explosion would instantly vaporize the metal. Scientists can create only a few thousand atoms of francium at a time in particle accelerators and laboratories. Research uses francium to test fundamental theories about atomic structure and the forces that hold matter together. Francium is like lightning captured in metallic form, too energetic to exist for more than moments. From francium's explosive flash, radium glows with historical tragedy. Radium, the glowing tragedy. Radium glows green in the dark with beautiful, deadly light that once fascinated and killed those who worked with it. With atomic number 88 and atomic mass 226, it radiates through group 2, period 7 with tragic beauty. This radioactive metal was once mixed into paint that glowed on watch dials and instrument panels. Radium melts at 700 degrees Celsius and glows continuously from its own radioactive energy, creating light without any external power source. Marie Curie discovered radium and won Nobel Prizes for her work, but eventually died from radiation exposure. Fun fact, radium was once added to toothpaste, cosmetics, and medicine because people thought radioactivity was healthy. Radium paint workers licked their brushes to make fine points, unknowingly poisoning themselves. Cancer treatment uses controlled amounts of radium radiation to destroy tumors, showing how dangerous elements can become healing tools when used wisely. Luminous paint on old airplane instruments and military equipment used radium that glowed for decades without fading. Radium carries both wonder and warning, beautiful light with a terrible cost. From radium's tragic glow, actinium opens a new series of heavy elements. Actinium, the blue pioneer. Actinium glows blue in the dark and opens the actinide series, beginning the heaviest naturally occurring elements. With atomic number 89 and atomic mass 227, it pioneers Group 3, Period 7 with radioactive leadership. This silvery white metal is intensely radioactive and generates heat from its own decay. Actinium melts at about 1050 degrees Celsius and emits enough radiation to excite the air around it, creating a faint blue glow. It was discovered by studying the radioactive decay of uranium ores. Fun fact, actinium's name means ray in Greek because it was discovered through its radioactive emissions. 1 gram of actinium produces as much heat as a small light bulb. Medical research uses actinium-225 in targeted cancer therapy that seeks out and destroys tumor cells while sparing healthy tissue. Actinium opens the gateway to the transuranium elements, heavy atoms that exist only through radioactive decay or artificial creation. It feels alive with nuclear energy, glowing with the power of atomic fire. From actinium's blue leadership, thorium follows with future promise. Thorium, the future fuel. Thorium could power the world with clean nuclear energy, abundant in the earth and safer than uranium. With atomic number 90 and atomic mass 232.04, it fuels Group 3, Period 7 with untapped potential. This silvery metal is 4 times more abundant than uranium and could provide electricity for thousands of years. Thorium melts at 1750 degrees Celsius and glows with bright white light when heated in air. Molten salt reactors could use thorium as fuel that cannot melt down or explode like traditional nuclear reactors. Fun fact, thorium was named after Thor, the Norse god of thunder, symbolizing its potential power. India and China are developing thorium reactors that could revolutionize clean energy. Gas lantern mantles once used thorium compounds that glowed brilliantly when heated by gas flames. Nuclear waste from thorium reactors would be dangerous for only 300 years instead of 10,000 years like uranium waste. Thorium feels like sleeping giant in the earth, waiting for humanity to unlock its peaceful atomic fire. From thorium's patient promise, protactinium whispers its rare secrets. Protactinium, the hidden precursor. Protactinium hides in uranium ores as one of the rarest naturally occurring elements, appearing only as uranium slowly decays. With atomic number 91 and atomic mass 231.04, it conceals itself in Group 3, Period 7 with mysterious scarcity. This dense, silvery metal is so rare that only a few grams exist in the entire world. Protactinium melts at about 1572 degrees Celsius and glows with metallic luster when freshly prepared. It was discovered by following the radioactive decay chain of uranium-235. Fun fact, protactinium's name means parent of actinium, because it decays to form actinium. It is one of the most difficult elements to study because it exists in such tiny quantities. Research laboratories use protactinium to understand the nuclear processes that create heavy elements in stars and supernovas. All the protactinium ever extracted would weigh less than a few coins, making it more precious than any jewel. Protactinium feels like a nuclear ghost, present but barely detectable in the atomic world. From protactinium's whispered secrets, uranium steps forward with world-changing power. Uranium, the atomic fire. Uranium contains the fire that powers nuclear reactors and the sun itself, holding enough energy to light cities or destroy them. With atomic number 92 and atomic mass 238.03, it burns through group 3, period 7 with cosmic power. This heavy, silvery white metal glows faintly green and can sustain nuclear chain reactions that release incredible energy. Uranium melts at 1135 degrees Celsius and tarnishes quickly in air, forming a black oxide coating. Nuclear power plants use uranium-235 that splits when hit by neutrons, releasing energy and more neutrons in a controlled chain reaction. Fun fact: uranium is naturally radioactive and has been slowly heating the Earth's core for billions of years. 1 kilogram of uranium contains as much energy as 2,000 tons of coal. The Manhattan Project used uranium to build the first atomic weapons, demonstrating both the promise and peril of nuclear energy. Medical isotopes made from uranium help diagnose and treat diseases in millions of patients worldwide. Uranium teaches us about responsibility in science, carrying both incredible potential and sobering consequences. After uranium's nuclear lessons, Neptunium continues the artificial journey. Neptunium, the artificial planet. Neptunium was the first transuranium element created by humans, named after the planet Neptune beyond Uranus. With atomic number 93 and atomic mass 237, it orbits group 3, period 7 in the realm of artificial elements. This silvery metal exists only because scientists learned to bombard uranium with neutrons. Neptunium melts at 644 degrees Celsius and exhibits multiple oxidation states that create colorful compounds in shades of green, yellow, pink, and blue. It was created in 1940 by bombarding uranium with neutrons in a cyclotron. Fun fact: Neptunium is produced naturally in trace amounts in uranium reactors when uranium-238 captures neutrons. It accumulates slowly in spent nuclear fuel. Space missions could use neptunium-powered batteries that generate electricity from radioactive decay for decades without solar panels. Though artificial, neptunium bridges the gap between natural uranium and the heavier synthetic elements that follow. It feels distant and mysterious, like its celestial namesake swimming in the outer solar system. From Neptunium's artificial orbit, plutonium rises with legendary power. Plutonium, the elemental demon. Plutonium burns with the fire of 1,000 suns and carries more concentrated energy than any element on Earth. With atomic number 94 and atomic mass 244, it explodes through group 3, period 7 with fearsome reputation. This dense, silvery metal feels warm to the touch from its own radioactive decay and glows faintly in the dark. Plutonium melts at only 640 degrees Celsius but releases so much energy that a baseball-sized sphere would kill anyone nearby with radiation. Nuclear weapons use plutonium-239 that explodes with the force of thousands of tons of dynamite. Fun fact: plutonium is one of the most toxic substances known, with microscopic amounts causing cancer and death. It remains dangerous for 24,000 years. Nuclear reactors can breed plutonium from uranium, creating more fuel than they consume in a process that could power civilization for millions of years. Space probes use plutonium batteries that work reliably in the cold darkness of the outer solar system for decades. Plutonium is atomic fire made solid, beautiful and terrible beyond imagination. After plutonium's legendary danger, americium protects our homes. Americium, the silent guardian. Americium sits quietly in smoke detectors throughout the world, protecting millions of families from fire with invisible radioactive sensors. With atomic number 95 and atomic mass 243, it guards group 3, period 7 from kitchen ceilings and hallways. This silvery white metal saves lives through gentle radiation that triggers alarms when smoke particles interrupt its path. Americium melts at 1176 degrees Celsius and glows with white light when heated. Smoke detectors use americium-241 that emits alpha particles safely contained in a small chamber. Fun fact: americium was first produced during the Manhattan Project and named after America. A typical smoke detector contains about 1 microgram of americium, roughly equivalent to a grain of salt. Industrial gauges use americium to measure the thickness of materials like paper, plastic, and metal without touching them. Oil well logging tools contain americium sources that help locate underground petroleum deposits by detecting different rock densities. Americium is a humble guardian, working silently in homes worldwide to save lives from fire. From americium's protective watch, curium glows with tribute to discovery. Curium, the glowing tribute. Curium glows red in the dark with its own radioactive fire, named after Marie and Pierre Curie, who pioneered radioactivity research. With atomic number 96 and atomic mass 247, it honors group 3, period 7 with luminous tribute. This dense, silvery metal generates so much heat from radioactive decay it glows like a tiny ember. Curium melts at 1345 degrees Celsius and produces enough heat to boil water just from radioactive decay. Space missions use curium in radioisotope thermoelectric generators that convert heat directly into electricity. Fun fact: curium was first created during World War II as a byproduct of plutonium production. 1 gram of curium generates about 3 watts of heat continuously. Alpha particle sources use curium for scientific research and industrial applications that require steady, controlled radiation. Deep space missions beyond Jupiter use curium power sources that work reliably where solar panels receive too little sunlight. Curium feels like a captured star, burning with the legacy of scientific pioneers who sacrificed their lives for knowledge. From curium's glowing tribute, berkelium continues the laboratory journey. Berkelium, the laboratory child. Berkelium exists only in scientific laboratories, created one atom at a time by bombarding americium with helium nuclei. With atomic number 97 and atomic mass 247, it experiments in group 3, period 7 purely for scientific knowledge. This radioactive metal has never been seen in quantities large enough to observe its physical properties. Berkelium would melt at approximately 986 degrees Celsius if enough could be produced to measure. It was first created at the University of California, Berkeley, using a 60-inch cyclotron. Fun fact: berkelium is named after Berkeley, California, where it was discovered. Only a few milligrams have ever been produced since its discovery in 1949. Research uses berkelium as a target material to create even heavier elements by bombarding it with lighter atomic nuclei. Nuclear scientists study berkelium to understand the fundamental limits of matter and how heavy atoms can exist. Berkelium feels like pure scientific curiosity made manifest, existing solely to expand human knowledge. From berkelium's laboratory existence, californium radiates with practical power. Californium, the neutron factory. Californium produces more neutrons per second than any other known source, making it incredibly valuable for starting nuclear reactors and analyzing materials. With atomic number 98 and atomic mass 251, it energizes group 3, period 7 with neutron radiation. This silvery metal is so intensely radioactive that microgram amounts glow visibly in the dark. Californium melts at about 900 degrees Celsius and emits millions of neutrons per second from spontaneous fission. A single microgram of californium, 252, produces 170 million neutrons per minute. Fun fact: californium is worth more than $25 million per gram, making it one of the most expensive materials on Earth. Only about 8 grams exist in the entire world. Nuclear reactors use californium neutron sources to start up safely and reliably. Medical devices use californium to treat certain cancers with neutron radiation therapy. Airport security systems use californium to detect explosives and nuclear materials by analyzing neutron interactions. Californium feels like bottled atomic energy, a key that unlocks the power of nuclear reactions. From californium's neutron mastery, Einsteinium burns with genius tribute. Einsteinium, the genius element. Einsteinium glows blue in the dark and honors Albert Einstein, the greatest scientific mind who revealed the relationship between matter and energy. With atomic number 99 and atomic mass 252, it illuminates group 3, period 7 with intellectual fire. This intensely radioactive metal exists only in tiny amounts created in nuclear reactors and weapons tests. Einsteinium melts at about 860 degrees Celsius and produces its own light through radioactive decay. It was first discovered in the debris of the first hydrogen bomb test in 1952. Fun fact: Einsteinium is named after Albert Einstein, whose equation E = mc² describes how matter converts to energy. Only a few milligrams have ever been produced. Scientific research uses Einsteinium to create even heavier elements and study the fundamental properties of superheavy atoms. The discovery of Einsteinium helped scientists understand how elements are created in stellar explosions and nuclear processes. Einsteinium feels like captured starlight mixed with human genius, burning briefly but brilliantly in honor of scientific achievement. From Einsteinium's brilliant tribute, fermium flickers with atomic history. Fermium, the atomic age witness. Fermium was born in the fire of nuclear weapons testing, created in the first hydrogen bomb explosion and named after Enrico Fermi. With atomic number 100 and atomic mass 257, it witnesses group 3, period 7 from the heart of atomic age history. This radioactive metal exists only in laboratories and the debris of nuclear tests. Fermium would melt at approximately 1527 degrees Celsius if enough could be created to measure. It was discovered by analyzing radioactive fallout from the first thermonuclear weapon test. Fun fact: fermium was kept secret for several years because its discovery revealed details about hydrogen bomb design. Enrico Fermi helped create the first nuclear reactor and atomic bomb. Research uses fermium as a stepping stone to create even heavier elements that exist for only milliseconds. Nuclear scientists study fermium to understand the limits of atomic stability and how matter behaves at the extremes of physics. Fermium feels like a trace of human history written in atomic fire, carrying the memory of scientific triumph and responsibility. From fermium's historical witness, Mendelevium appears with systematic tribute. Mendelevium, the table maker's honor. Mendelevium honors Dmitry Mendeleev, the Russian genius who created the periodic table and predicted elements before they were discovered. With atomic number 101 and atomic mass 258, it organizes group 3, period 7 with systematic respect. This radioactive metal exists only as individual atoms created one at a time in particle accelerators. Mendelevium would melt at approximately 827 degrees Celsius if sufficient quantities could be produced. It was first created by bombarding Einsteinium with helium nuclei in a cyclotron. Fun fact: mendelevium was the first element created one atom at a time and identified by tracking individual radioactive decay events. Mendeleev predicted the existence of many elements that were later discovered exactly as he described. Scientific research uses mendelevium to explore the fundamental limits of atomic structure and test theories about how heavy elements can exist. The periodic table that organizes all chemistry began with Mendeleev's brilliant insight into the patterns of elemental properties. Mendelevium feels like respect crystallized into matter, honoring the systematic mind that brought order to chemical chaos. From Mendelevium's systematic honor, nobelium shines with peace tribute. Nobelium, the Peace Prize element. Nobelium honors Alfred Nobel, who created the Nobel Prize to reward those who benefit humanity through science and peace. With atomic number 102 and atomic mass 259, it awards group 3, period 7 with Nobel recognition. This radioactive metal exists only as isolated atoms created in the most advanced particle accelerators. Nobelium would melt at approximately 827 degrees Celsius based on theoretical predictions. It was first reliably created by bombarding curium with carbon nuclei. Fun fact: nobelium was named after Alfred Nobel, who invented dynamite but used his fortune to establish prizes for peace, literature, and science. The discovery of nobelium was disputed for years between American and Soviet scientists. Nuclear physics research uses nobelium to study the properties of superheavy elements and test theoretical models of atomic structure. Nobel Prizes continue to honor scientists who expand human knowledge and work for the betterment of mankind. Nobelium feels like a reminder that science should serve humanity's highest aspirations for peace and progress. From nobelium's peaceful tribute, Lawrencium follows with accelerator legacy. Lawrencium, the accelerator pioneer. Lawrencium honors Ernest Lawrence, who invented the cyclotron and made it possible to create artificial elements. With atomic number 103 and atomic mass 262, it accelerates group 3, period 7 with technological tribute. This radioactive metal marks the end of the actinide series and exists only as individual atoms lasting seconds or minutes. Lawrencium would melt at approximately 1627 degrees Celsius if enough atoms could be assembled. It was created by bombarding californium with boron nuclei in a linear accelerator. Fun fact: Lawrencium is named after Ernest Lawrence, who won the Nobel Prize for inventing the cyclotron particle accelerator. The element completes the actinide series, just as lutetium completes the lanthanides. Particle physics research uses Lawrencium as a bridge to understanding the superheavy elements that follow. Lawrence's cyclotron invention made it possible to create all the transuranium elements that don't exist naturally. Lawrencium feels like a doorway between the naturally radioactive actinides and the purely artificial superheavy elements beyond. From Lawrencium's technological legacy, Rutherfordium begins the superheavy frontier. Rutherfordium, the nuclear pioneer. Rutherfordium honors Ernest Rutherford, who discovered the atomic nucleus and founded nuclear physics. With atomic number 104 and atomic mass 267, it pioneers Group 4, Period 7 in the realm of superheavy elements. This radioactive metal exists for only seconds before decaying and has never been seen in visible quantities. Rutherfordium would theoretically melt around 2100 degrees Celsius based on its position in the periodic table. It was first created by bombarding plutonium with neon nuclei in particle accelerators. Fun fact: Rutherfordium was the subject of a naming controversy between American and Soviet scientists for over 20 years. Rutherford split the atom and discovered that atoms have dense, tiny nuclei. Nuclear research uses Rutherfordium to explore the theoretical island of stability, where superheavy elements might last longer. Modern nuclear physics began with Rutherford's gold foil experiment that revealed atomic structure. Rutherfordium feels like standing at the edge of known matter, pushing into the realm where atoms exist only briefly before vanishing. From Rutherfordium's nuclear foundation, dubnium adds international cooperation. Dubnium, the collaborative bridge. Dubnium honors the town of Dubna, Russia, where international scientists work together to create the heaviest elements. With atomic number 105 and atomic mass 268, it cooperates across Group 5, Period 7 with diplomatic harmony. This superheavy metal exists only in particle accelerators where atoms from different nations collide to create new elements. Dubnium would theoretically melt around 2300 degrees Celsius if sufficient atoms could be collected. It was created by bombarding americium with neon nuclei at the Joint Institute for Nuclear Research in Dubna. Fun fact: dubnium represents international scientific cooperation between American, Russian, and European researchers. Dubna is home to the world's most powerful heavy ion accelerators. Scientific collaboration uses dubnium research to unite physicists from former enemy nations in peaceful exploration of matter's limits. The creation of superheavy elements requires cooperation between countries with the most advanced nuclear technology. Dubnium feels like a bridge between nations, showing how science transcends political boundaries. From dubnium's cooperative spirit, Seaborgium enters with discovery dedication. Seaborgium, the element hunter. Seaborgium honors Glenn Seaborg, who discovered more elements than any person in history and reshaped the periodic table. With atomic number 106 and atomic mass 269, it discovers Group 6, Period 7 with relentless curiosity. This superheavy metal exists only as isolated atoms that decay within seconds of creation. Seaborgium would theoretically melt around 2700 degrees Celsius based on its chemical properties. It was created by bombarding lead with chromium nuclei in particle accelerators. Fun fact: Seaborgium was named after Glenn Seaborg, who discovered 10 transuranium elements and was the first living person to have an element named after him. He reshaped the periodic table by adding the actinide series. Element synthesis research uses Seaborgium to test theoretical predictions about superheavy element chemistry. Seaborg's discoveries opened the door to creating elements that exist nowhere naturally in the universe. Seaborgium feels like scientific persistence made atomic, carrying the spirit of endless discovery into the unknown. From Seaborgium's hunting legacy, Bohrium glows with quantum tribute. Bohrium, the quantum master. Bohrium honors Niels Bohr, who revealed how electrons orbit atomic nuclei and founded quantum mechanics. With atomic number 107 and atomic mass 270, it orbits group 7, period 7 with quantum elegance. This super-heavy metal exists only as individual atoms that last mere seconds before radioactive decay. Bohrium would theoretically melt around 2,400 degrees Celsius if enough atoms could be assembled. It was created by bombarding bismuth with chromium nuclei in heavy ion accelerators. Fun fact, bohrium is named after Niels Bohr, who won the Nobel Prize for describing atomic structure and electron energy levels. The Bohr model of the atom shows electrons orbiting the nucleus like planets around the Sun. Quantum physics research uses bohrium to test how quantum mechanics applies to the heaviest possible atoms. Bohr's insights into atomic structure made modern chemistry and nuclear physics possible. Bohrium feels like quantum theory crystallized into matter, carrying the elegant mathematics of atomic behavior to the very limits of nuclear stability. From bohrium's quantum beauty, hassium follows with German precision. Hassium, the precision element. Hassium honors the German state of Hesse, home to the heavy ion research facility where superheavy elements are precisely created. With atomic number 108 and atomic mass 277, it engineers group 8, period 7 with technical excellence. This superheavy metal exists only as isolated atoms produced in the world's most sophisticated particle accelerators. Hassium would theoretically melt around 2,400 degrees Celsius based on its predicted metallic properties. It was created by bombarding lead with iron nuclei at the GSI facility in Darmstadt. Fun fact, hassium is named after Hesse, Hascha in Latin, the German state where it was discovered. Only a few atoms of hassium have ever been created, each lasting less than 10 seconds. Nuclear engineering research uses hassium to explore the fundamental limits of matter and test theories about atomic stability. German precision engineering makes possible the incredible accuracy required to create superheavy elements. Hassium feels strong yet elusive, representing human technical mastery pushing against the very boundaries of physical reality. From hassium's precision engineering, meitnerium shines with justice restored. Meitnerium, the justice element. Meitnerium honors Lise Meitner, the brilliant physicist who explained nuclear fission but was denied recognition during her lifetime. With atomic number 109 and atomic mass 278, it corrects group 9, period 7 with long overdue justice. This superheavy metal exists only as individual atoms that decay within milliseconds, but its name lasts forever. Meitnerium would theoretically melt around 2,000 degrees Celsius if sufficient quantities could be produced. It was created by bombarding bismuth with iron nuclei in particle accelerators. Fun fact, meitnerium honors Lise Meitner, who discovered nuclear fission but was overlooked for the Nobel Prize because she was a woman. She explained how uranium nuclei split apart, making nuclear power and weapons possible. Nuclear physics research uses meitnerium to study the properties of superheavy elements and atomic decay processes. Meitner's theoretical insights explained how stars create energy and how nuclear reactors work. Meitnerium feels like justice restored, giving eternal recognition to a brilliant mind that was unfairly forgotten by history. From meitnerium's corrected legacy, Darmstadtium arrives with discovery dedication. Darmstadtium, the discovery engine. Darmstadtium honors Darmstadt, Germany, where the world's most powerful heavy ion accelerator creates elements that never existed before. With atomic number 110 and atomic mass 281, it accelerates group 10, period 7 with discovery power. This super-heavy metal exists only as fleeting atoms that vanish almost as quickly as they appear. Darmstadtium would theoretically melt around 1,800 degrees Celsius based on its position in the periodic table. It was created by bombarding lead with nickel nuclei at the GSI Helmholtz Center. Fun fact: Darmstadtium is named after Darmstadt, the German city that houses the world's leading heavy element research facility. Each atom lasts only about 10 seconds before decaying. Particle acceleration research uses Darmstadtium to explore the theoretical limits of how heavy atoms can become. The GSI facility in Darmstadt has discovered 6 super-heavy elements using the most advanced ion beam technology. Darmstadtium feels like a passing spark of discovery, reminding us that scientific exploration never ends. From Darmstadtium's fleeting presence, Röntgenium glows with X-ray tribute. Röntgenium, the X-ray vision. Röntgenium honors Wilhelm Röntgen, who discovered X-rays and gave humanity the power to see inside the human body. With atomic number 111 and atomic mass 282, it penetrates group 11, period 7 with invisible insight. This super-heavy metal exists only as individual atoms lasting seconds before decay. Röntgenium would theoretically melt around 1,100 degrees Celsius if enough atoms could be collected. It was created by bombarding bismuth with nickel nuclei in particle accelerators. Fun fact: Röntgenium honors Wilhelm Röntgen, who won the first Nobel Prize in Physics for discovering X-rays. He called them X-rays because their nature was unknown, and the name stuck. Medical imaging research uses Röntgenium experiments to understand atomic properties that might lead to new diagnostic techniques. Röntgen's discovery of X-rays revolutionized medicine and saved millions of lives through early disease detection. Röntgenium feels like hidden light made atomic, carrying the legacy of seeing the invisible into the realm of super-heavy elements. From Röntgenium's penetrating vision, Copernicium turns the cosmic wheel. Copernicium, the cosmic revolutionary. Copernicium honors Nicholas Copernicus, who placed the sun at the center of the solar system and revolutionized human understanding of the cosmos. With atomic number 112 and atomic mass 285, it revolves through group 12, period 7 with cosmic significance. This super-heavy metal might behave more like a noble gas despite being metallic. Copernicium would theoretically be liquid or gas at room temperature, unlike other metals in its group. It was created by bombarding lead with zinc nuclei in particle accelerators. Fun fact: Copernicium is named after Nicholas Copernicus, who proved that Earth orbits the Sun other than the universe revolving around Earth. This super-heavy element might have very unusual properties. Theoretical chemistry research uses copernicium to test how relativistic effects change the properties of the heaviest elements. Copernicus literally turned the universe inside out by showing that humans are not at the center of everything. Copernicium feels cosmic and revolutionary, carrying the spirit of overturning accepted truth through careful observation and brave thinking. From Copernicium's cosmic revolution, Nihonium steps forward as one of the newest discoveries. Nihonium, the rising sun element. Nihonium is one of the 4 newest elements, discovered in Japan and named after Nihon, the Japanese word for Japan. With atomic number 113 and atomic mass 286, it honors group 13, period 7 with Eastern achievement. This super-heavy metal represents Asian excellence in nuclear physics and international scientific competition. Nihonium would theoretically melt around 700 degrees Celsius if sufficient quantities could be produced. It was created by bombarding bismuth with zinc nuclei at the Riken Research Institute in Japan. Fun fact: nihonium was the first element discovered in East Asia, marking Japan's leadership in superheavy element research. Asian scientists are now major players in expanding the periodic table. Nuclear research uses nihonium to explore the predicted island of stability, where superheavy elements might last much longer. Japanese precision and dedication in nuclear physics led to this historic discovery after decades of patient work. Nihonium feels like the rising sun illuminating new regions of atomic territory. From nihonium's eastern achievement, flerovium continues with Russian excellence. Flerovium, the laboratory legend. Flerovium honors the Flerov Laboratory of Nuclear Reactions in Russia, where international teams create the heaviest elements through atomic fusion. With atomic number 114 and atomic mass 289, it fuses group 14, period 7 with collaborative research. This superheavy metal might be surprisingly stable and could exist long enough to study its properties. Flerovium would theoretically melt around 200 degrees Celsius, possibly making it liquid at room temperature despite being a metal. It was created by bombarding plutonium with calcium nuclei in particle accelerators. Fun fact: flerovium is named after Georgy Flerov, who founded the laboratory that has discovered many superheavy elements. It might have a half-life of several seconds, making it relatively stable. International nuclear collaboration uses flerovium research to unite scientists from around the world in peaceful atomic exploration. The Flerov Laboratory represents decades of Russian leadership in superheavy element discovery. Flerovium feels like teamwork crystallized into matter, showing how cooperation creates scientific achievements impossible for any single nation. From flerovium's collaborative fusion, moscovium rises with capital recognition. Moscovium, the capital element. Moscovium honors Moscow, the Russian capital where nuclear physics was born and superheavy elements are still discovered. With atomic number 115 and atomic mass 290, it governs group 15, period 7 with metropolitan authority. This superheavy metal exists only as individual atoms that decay within milliseconds of creation. Moscovium would theoretically melt around 700 degrees Celsius if enough atoms could be assembled to measure. It was created by bombarding americium with calcium nuclei in cyclotron accelerators. Fun fact: Moscovium is named after Moscow, the city that has been the center of Russian nuclear research for over 70 years. Soviet and Russian scientists have discovered more superheavy elements than any other nation. Nuclear diplomacy research uses moscovium to maintain peaceful scientific relationships between nations with nuclear technology. Moscow remains a major center for theoretical and experimental nuclear physics research. Moscovium feels like political power transformed into atomic achievement, representing national pride expressed through scientific discovery. From Moscovium's capital authority, Livermorium follows with American partnership. Livermorium, the partnership element. Livermorium honors the Lawrence Livermore National Laboratory in California, where American scientists collaborate with Russian researchers to create superheavy elements. With atomic number 116 and atomic mass 293, it partners group 16, period 7 with international friendship. This superheavy metal represents peaceful cooperation between former nuclear rivals. Livermorium would theoretically melt around 700 degrees Celsius and might be surprisingly stable for a superheavy element. It was created through collaboration between American and Russian scientists bombarding curium with calcium. Fun fact: Livermorium represents the peaceful partnership between Livermore Laboratory and Russian nuclear institutes. Former enemies now work together to expand human knowledge. Scientific diplomacy uses Livermorium research to maintain peaceful relationships through shared discovery of new elements. American and Russian nuclear scientists share data and celebrate discoveries together despite political tensions. Livermorium feels like friendship forged in atomic fire, proving that science can unite nations in common purpose. From Livermorium's peaceful partnership, Tennessine brings American recognition. Tennessine, the Southern Discovery. Tennessine honors the state of Tennessee, home to Oak Ridge National Laboratory, where nuclear elements are created for research worldwide. With atomic number 117 and atomic mass 294, it represents Group 17, Period 7 with Southern scientific achievement. This superheavy halogen might have unusual properties unlike other elements in its group. Tennessine would theoretically melt around 700 degrees Celsius and might be metallic despite being a halogen. It was created by bombarding berkelium with calcium nuclei through American-Russian collaboration. Fun fact: Tennessine is named after Tennessee, where the Manhattan Project began and nuclear research continues today. It might be the first halogen that acts like a metal. Nuclear medicine research uses materials from Tennessee laboratories to create medical isotopes that diagnose and treat diseases. The state that helped end World War II now contributes to peaceful nuclear applications. Tennessine feels like Southern hospitality extended to the atomic realm, welcoming new discoveries with traditional American values. From Tennessee's regional pride, we reach the final element in our journey. Oganesson, the edge of everything. Oganesson is the heaviest and final element in our current periodic table, named after Yuri Oganesson, who has discovered more superheavy elements than any living scientist. With atomic number 118 and atomic mass 294, it completes Group 18, Period 7 at the very edge of known matter. This mysterious noble gas might actually behave like a metal, defying all expectations. Oganesson would theoretically be solid at room temperature despite being a noble gas, with unprecedented properties that challenge our understanding of chemistry. It was created by bombarding californium with calcium nuclei in the most advanced particle accelerators. Fun fact: Oganesson honors Yuri Oganesson, the Armenian-Russian physicist who has spent his career pushing the boundaries of nuclear physics. It might be metallic and reactive despite being in the noble gas column. Theoretical physics research uses Oganesson to test the fundamental limits of matter and explore whether even heavier elements might exist. Oganesson's lifetime of research has expanded the periodic table into realms that exist nowhere naturally in the universe. Oganesson feels like standing at the very edge of physical reality, where human curiosity meets the fundamental laws of atomic structure. And from Oganesson's mysterious frontier, the story of the periodic table pauses, waiting for the next discovery that will push even further into the unknown realms of superheavy elements. The journey continues, as human curiosity and scientific determination work together to unlock the secrets of matter itself, one atom at a time, one discovery at a time, forever expanding our understanding of the universe we call home. The elements have told their stories, from hydrogen's simple beginning to Oganesson's complex ending. Each one carries the history of stars, the creativity of nature, and the endless curiosity of human minds. Sleep now, with the periodic table complete in your dreams, knowing that tomorrow will bring new discoveries and new elements yet to be named. Thank you for joining this gentle journey through chemistry's greatest treasures. Sweet dreams, and may the elements dance peacefully in your mind until morning comes again.